conducting two competitions for students. First one is CanSat competition and another one is rocketry competition. Our university is participated in both the competition and we got selected into the final stage of it. So the first stage belongs to PDR, preliminary design review. It is the review where we are going to give our ideology approach towards the system. So the major objective of this CanSat is to develop a can-sized satellite which should height minimum of 40 centimeter and with a radius of 15 centimeter, and it should consist of all the subsystems. It has like EPS, communication subsystems, and the parachute control mechanism and gyro control mechanism. So the CanSat will be launched in a height of 1000 meters, and when it comes to 600 meters, it should deploy a parachute and it should stabilize itself. Let me give you an example. If we are throwing a bottle from 5th floor of this block, it will be not coming the same speed. It should descend in 1 to 3 meters per second. So that we are going to use a parachute mechanism. To open the parachute mechanism, we have given a unique approach to it. So that is a linear servo mechanism. So linear servo mechanism will be briefing it that in the next few slides. Before that, this is we have proposed the CanSat in a cylindrical body which has honeycomb structure in it. Why we used honeycomb structure is to increase the strength of the structure and to decrease the weight. The conditions of this competition is to not exceed more than 1 kg. So designing a CanSat is easy, but maintaining the weight constraints are too difficult to do while we are approaching towards this ideology. So first thing, this has a height of 40 centimeter, that is 400 mm, and a diameter of 15 centimeter, and a thickness, wall thickness of 3 mm. So these are the just inner and outer shell of the CanSat. So moving on to the innovation adapted. What innovation we have shown towards this approach is we have designed a 2-axis gimbal-based gyro mechanism. So basically we use our phone, right? It has a gyroscopic sensor. When you tilt the phone, it just rotates. For example, some of the students will be playing their own games like Free Fire or PUBG. When we are like tilting the phone, gyro mechanism will be activating. So that sensor we are going to inbuilt in this CanSat to make the CanSat stabilize. So what that gyro sensor will do is this CanSat is in this altitude and this rotation. So we have to stabilize it to 0.0 degree rotation. It will be intimating the microcontroller. The microcontroller which we have proposed is TNZ 4.1. It's an ARM-based microcontroller. So it will be intimating the microcontroller to say the gimbal mechanism, the second one. The gimbal mechanism to make the CanSat to stabilize in the particular angle which we needed. So this is the actual setup which we have did, and another interesting part in it is we have used a recycled HDD, hard disk batteries. So hard disk basically has a BLDC motors which has 7000 RPM in it. So we use that disk and that motor to generate the particular amount of torque needed to stabilize the CanSat. For example, Bono is here. So if I need to push him, I need to give a particular amount of force to make him to move to that stage. So like the same way, for stabilizing the 1 kg CanSat, I need to generate some particular torque to stabilize it in 30 degree radians per second. So moving on to the parachute mechanism, to give it an innovative approach, we plan to deploy it with 4-stage parachute mechanism. So the 4th video you can like see. So as you can see, we just tested our parachute mechanism from our 4th floor. So it makes the CanSat to land in 1 to 3 meters per second. Moving on to the next slide. So CanSat descent control mechanism. So the parachute will be inside the can-sized satellite. So it will be of 40 centimeter, right? The particular above 10 centimeter place will be for the parachute. So once it reaches 600 meters, it should deploy the parachute. So we have to propose a mechanism for it. So we proposed linear servo mechanism. When the CanSat reaches 600 meters, it will release the parachute and it will be deploying out when it reaches 600 meters. So these are the parachute calculations. This is like a more theoretical way which we have proposed to the in-space. So this is the advanced gyroscope mechanism. We are going to use PID control loop algorithm. So what it does, it intimates the IMU, that is initial measurement unit. We first, like, initial approach our team, like, we sat and we were like thinking what sensors we need to use, because in market there are many IMUs are there which has like 0.1 degree error, 0.23 degree error. So we came into a conclusion we are going to use Adafruit BNO 005 9-axis IMU. The 9-axis IMU is 3-axis gyroscope and 3-axis accelerometer, 3-axis magnetometer. This IMU, it will intimate the microcontroller what we have proposed CNC, and it will say to correct the error which is occurring in that. That is what the PID control loop algorithm means. So moment of inertia, these are the required torque which we needed to generate to stabilize the CanSat. So the disk, we are using the third imager. We are using a BLDC motor which is extracted from HDD hard disk, and we'll be using a honeycomb structured reaction wheel in it. What does the reaction wheel do? When the motor rotates, the reaction wheel spins. So when the reaction wheel spins, it generates a particular amount of torque or a force which will make the CanSat to stabilize itself. So moving on to the avionics and those parts, my colleague will be explaining in detail about what is what and the what sensors we have been using in this.
Good morning, everyone. So, in this CanSat project, based on the mission target, we will decide the sensors and payloads we are going to use. So, there are the 3 missions in the CanSat project. First one, sending data packets. In the data packets, this list of temperature, pressure, and IMU sensor, accelerometer. These type of data has to be sent for every second when it's in the flight time. So for this we are using these sensors. XB Pro 1 S1 is a module which will send the data from a CanSat module to antenna. Through that we can establish a communication link between the CanSat and the ground station. And next one, DPS 310. It's an IMU sensor. And next, DPS 310 is a temperature and atmosphere sensor. And next one, BNO 059 is an IMU sensor. And RTC, real-time clock sensor. In the data packet, we have to send in which time that temperature or atmosphere pressure has been decided, that time has to be sent also in the packet. And next, BZ110dB, that is a buzzer sensor. After landing onto the ground, it will generate sound too easy to identify. And next one, SD card. We are placing 2 camera sensors, primary and secondary. So for capturing the images, and it will store in the local storage in SD card. After recovering the satellite, we will extract the data and will show to the competition authorities. And next one, RDoCam. This is the primary camera which is placed in the top of the CanSat for capturing the deployment of the parachute. It's deployed perfectly or not. And next one, ESP32 cam. It will be placed at the bottom of the CanSat. It will capture the terrain photos, and after recovering from it, we will make 3D terrain mapping from the images. And next one, 2.4 gigahertz rubber duck antenna. This we have different types of antenna and different range also. But this is the perfect rubber duck antenna for placing in the CanSat, as per the height and weight also. And next, EPS subsystem, power subsystem, handling the for which sensor power consumption has been sent in which measurement. And next one, sensor subsystem. You can see the each sensor what is sending. DPS 310 atmospheric and temperature, and BNO orientation like 9-axis. Navic GNS chip we are adding as a sensor for getting the GPS location with longitude and latitude. And next one. And next we'll move to the next slide. So this is the ground station module. So in this project we have to place we have to be an remote ground station which has to be connected through the laptop. So for this, we have created a web application using React for getting the data, and it should represent in the website. So this data has to be update real time and lively. Then only the competition will be, we will be in success. And next one, in the ground station, there will be totally 4 major pads. One is the Yagi-Uda antenna. We are using the Yagi-Uda antenna because of its range and the it has more role, everything. And the next one, XB Pro. It will get the signal it's getting, it will be tuned, and that can be used into the data as receiving. And next one is the XB module, that another XB module which we can connect from the XB Pro series sensor to the our laptop. That will help into the connecting to the ground station. So for establishing a communication path between the CanSat and the ground station, this antenna, rubber duck antenna in CanSat and Yagi-Uda antenna in the ground station will have the XB Pro module for tuning the data packets that which we are sending into the ground station. Yeah, thank you.
Before moving on that, just a minute, sir. This is the actual flight software which we have designed. Our colleague Arichulam has designed, and will be receiving all the major data which we needed for the CanSat project. Just Google, scroll down. So this is the actual. This is dummy data we have fed, and this is the actual flight software which we have designed. Thank you.
We'll continue after a while. Thank you. We are marching towards Session 4, Day 2 of the seminar, for which we invite Geeta ma'am, Head of the Department, Computer Science and Engineering. She obtained her PhD from Jawaharlal Technological University, and she has expertise over machine learning, data mining, and knowledge discovery. We are happy to have you as our chairperson, ma'am. We have Dr. K. Divya, HOD of BME, to take as a co-chair of the day. She obtained her PhD from Anna University in the year 2017, and she has rich experience and expertise over image processing, biomedical waste management, digital signal processing. We are happy to have you, ma'am.
Very good
No,
morning.
I can't hear you. Am I audible to you? Are you muted?
Yes, sir. Yes, you are audible. Are you hearing our voice, sir?
But I can't hear you. Whether
Can you able to hear our
which
voice?
speaker we should select?
Can you able to hear us?
Yeah, now you are audible.
Yes, sir. Thank you. Thank you.
Yes, madam. Thank you.
Dr.M.G.R. Educational Research Institute and Space Technology, happy to welcome today's speaker, Dr. Vinod Kumar sir. I'm very happy to introduce our today's speaker, Vinod Kumar sir, who is Director, Promotion Directorate in Space, Department of Space, Executive Secretary, Astronautical Society of India, Government of India. Today, sir is going to share the content about expanding the horizons of Indian commercial space sector through policy, regulation, and collaboration. InSpace, launched in 2020, is transforming India's space sector by promoting private participation with over 600 proposals and 8,000 plus registrations. The government now allows up to 100% FDI and 49% in launch vehicles, 74% in satellites, and 100% in subsystems under the Indian Space Policy 2023.
It's too much moving. Camera, can somebody hold it, please? It is too much moving here and there. Thank you. Please hold the camera at one location. Thank you.
Supportive schemes like the rupee 1 crore seed fund and 500 crore technology adoption fund and a 2-year pre-incubation program are empowering startups. A 1,000 crore venture capital fund further fuels innovation. India's historic lunar South Pole landing showcases its global potential. In-space is paving the way for global collaboration and thriving a space economy. Now I invite my co-chair to introduce Dr. Vinod Kumar sir profile. We welcome you once again, sir.
Dr. Vinod Kumar is the Director of the Promotion Directorate at InSpace under the Department of Space, Government of India. A seasoned leader in India's space sector. He combines technical acumen with strategic vision and a passion for space exploration. Before InSpace, he served for nearly 25 years at the URRAO Satellite Center, ISRO Bengaluru, where he led the GEO Control Dynamics Design Division and was Deputy Project Director for the Attitude and Orbit Control System. Dr. Vinod Kumar is the Director of the Promotion Directorate at InSpace under the Department of Space, Government of India. Dr. Vinod played vital roles in India's lunar missions, serving on Chandrayaan-2 Peer Review Committee, leading anomaly analysis during Vikram landers, powered descent, and contributing to Chandrayaan-3 as a member of the Standing Design Review Committee for NGC systems. He also chaired the committee that reviewed functional requirements for the Aditya L1 mission. He received the ISRO Team Excellence Award twice in 2006 from Dr. APJ Abdul Kalam for in-orbit spacecraft operations, and in 2011 for the AOCS design of GSAT-12. An alumnus of IIT Bombay, Dr. Vinod earned his PhD in autonomous navigation for collocated GEO satellite using IRNSS NAVIC. He is a certified ISO N9001 2015 lead auditor, Indian Institute of Quality Management. Holds a patent on a vision-based autonomous planetary landing system, and he has authored over 40 publications in national and international journals. He serves as the Executive Secretary of Astronautics of Institute and the Institute of Electronics and Telecommunication Engineers. His technical interests include AI, missile detection, time navigation, pulsar navigation, planetary reentry, Mars exploration, and interplanetary missions. Prior to URSC, he worked with the Indian Air Force on fighter aircraft control systems and held academic roles at REC Haryana and SJP-ML Institute of Technology, Radar, reflecting a career that bridges research, operations, and education. Thank you. Welcome you, sir.
Thank you, madam. Audible? Yeah. My presentation to make you a little bit this. How to present? Am I presenter? Share. Send request. I think somebody has to make me. Can you make me presented, admin, please? Yeah, I can. Share window. You can see my screen? Yeah. So first of all, let me thank Dr. Viswanathan-G, Rector for Dr.M.G.R University and other officials for giving me this opportunity to interact with students. And I really appreciate the enthusiasm of Dr.M.G.R University. I personally know from CanSat, your teams has participated last year also, and this year also you are at CDR faced. I think water rocketry and both the teams, two teams are there or one team from your college? Excellent. So that's all your interest, and because of very busy schedule, night 1 o'clock only I have reached from Delhi, so I could not travel. But next time certainly I will come and interact with the students there. It's so nice to be a part or to interact with the students. I really like. So, friends, the purpose of this was to give you the how Indian commercial space sector is being led by Indian space. We are spreading the wing of the Indian commercial space sector. As you all know, that prior to space sector reform in 2020, June 2020, the private companies were working for space sector, but they were working as vendor. But the present government, led by Honorable Prime Minister, took decision in June 2020 that space is for all. So he has opened the gates of space to participation in the end-to-end activities in June 2020 that each Indian can work in the space sector. How it can work, how in space is doing, I will discuss all these things. Friends, as you all know that it all started very humble beginning for it getting the nose cone on a bicycle to a macho vehicle where 36 satellites are being transported, and we have launched 72 satellites into missions. Earlier world record 4 satellites. So this is a kind of humble beginning to a macho vehicle we have in the launch. And now see here, 40-watt power. Aryabhata satellite was launched in 1975, 19 April 1975, and from that day onwards, Aryabhata Satellite Technology Day is celebrated every year on 19th of April. So it is just so we and satellite 14,000 watt, 40 watt to of RGs. Coming out with innovative ways to test satellite. It was in during Aryabhata days where they want to test the RF interference. Rather than spending crores in foreign facilities, they found a way how we can do with the help of block card. And they paid 156 rupees, where foreign country asked 2 crore in 1970, that time frame. You see how we are known to do the quality work. And presently, you see, we have the state-of-art facility where right side this satellite is being done for RF testing. Now, you see, having developed the capacity and capability in each sector of the space, there is a need to take it forward. How? I will divide first space in the 4 phases. If you see space observation, you know the early astronomical and astrology, India's contribution is well known. Aryabhata in 500 AD had documented precise planetary motions. He has told that sun is the center of universe, it is not Earth. Around more than 1,500 years back. And if you read history, the Western, the most innovative countries, till 1600 AD, they were not knowing that whether Earth is the center or Sun is the center of the universe. So you can see our great astronomers, how they could compute. You must read the Aryabhatam by Aryabhata. It's a very interesting book where he details the planetary motion. It has 4 chapters. So I encourage you to read. So that was our contribution to the astronomical observations, which our many reading has gone to the West and come back to us. Then came Space 2, where race to space began. Spacefaring nations were racing me first, me first. But what was the outcome? Outcome was it led to the Apollo moon landing in 1969. Then came space is a very deep pocket and deep tech area, so let us collaborate. So this cooperation and collaboration led to the International Space Station. In 1998, this is a very unique piece by mankind where 16 plus nations has come together and built that International Space Station. It has given a lot of learning to the mankind and advantages. Then came, now over the time, the application of space has touched the human life. You get up in the morning, you watch news, there is a space technology behind. You go to your office or college, you see the navigation apps, there is a space technology acting behind. Yeah, by the way, I don't know how many of you know that there is a one Google app, I know, I'm sure you will all be knowing, but there is a one Indian app also, that is, can anyone say? Indian navigation app. So you should see that Maple app. Map My India app is the Maple app. So you should use that also and see. You can use our own satellite constellation and start doing that. Right? So what happened? So space technology is behind that. They'll go to ATM. There's a space technology behind working. You see the weather. There is a space technology. We have saved millions of lives by forecasting weather in a very precise manner. And even in advance information of upcoming hurricanes and cyclones has helped the district administrations to move the people to the other safe places and save the lives. Space technology is touching everyone's life. Now you see the space technology, even in agriculture sector, precision agriculture they are doing. You can identify the properties of leaves, identify the soil health card. You can do many things with the space technology. You must have learned about the PM Gati Shakti model, where they are saving hundreds of crores in cost as well as time by planning the highways, railways, and any other things in a week's time or 2 weeks' time. So, having seen this, there was a paradigm shift for commercialization of space. It started in around 2000 in other countries and prior, but we were not to be led behind with the visionary leadership of Sri Narendra Modi ji. Government of India carried out a wide space sector reform, where they formed an autonomous body called Indian National Space Promotion and Authorization Center on 24 June 2020, which enables private sector to carry out end-to-end activities. You see, this was, as I have told earlier, it is a total dramatic shift from a vendor to ISRO. Now, any one of you can do what ISRO was doing. You can make your own satellite launch vehicle. सभी खड़े हो गए? What happened? All well? Shall I continue? Hello, sir. So if you see that in space, after space sector reform, any Indian company or individual were permitted to carry out end-to-end space activities. So opportunity was given to all the Indian citizens. Now what we do, we address, we promote, we authorize, we enable, we supervise the private companies, and we are a single window agency. In space board, space has autonomous body, it has board members from Department of Space, ISRO, various ministries, industry, and academia. As you know, New Space India Limited is a commercial arm of the ISRO, and this will carry end-to-end demand-based services, commercial production, and technology transfer. ISRO, you need no introduction what ISRO has contributed to the national development and the development of space in each sector. So coming back to in space, sorry, we are a regulator of the space, but space companies are at very nascent stage, so we need to promote also. So these are the some 4 roles which we see is promoter, enabler, authorizer, and supervisor. As a promoter of space, we have drafted with Department of Space strategy for decadal vision and strategy for Indian space sector. I will present some slides. We carry out industry outreach by devising a scheme for their growth, like fund scheme, I'll touch upon them. We engage with academia, subject BTech Space Technology minor, which I'm very happy to tell that All India Council of Technical Education has approved the same and it is available for adoption by any institution across India. We are working with 14 institutions and universities to adopt the space technology, and many has already started adopting them. International outreach also one of the vertical in space for commercialization of space and connecting private sector to the foreign players. As the enabler, we nurture and support state startups, enable access to ISRO space facilities and technologies. It's very important that space business is a very costly, deep pocket and deep tech business. So we are happy to inform you that ISRO has already transferred around 80 technologies to private sector for commercialization and scaling up. Any private company can use the space ISRO labs to test their product. Additionally, we at InSpace has made one technical center where end-to-end design you can carry out. We have it is a very high-tech facility with high fidelity models to design your product, test your project, assemble your project, and take to launch pad. So these are the some certain things which we are doing as an enabler. Authorization, I have told that we authorize the private company after facilitating proper reviews, and we are acting as a single window agency as well. Means if a private company comes, various department permission, they have to apply it to InSpace, and we will ensure that it goes through all the department. He need not to run around various department. So this is the structure where you see that Chairman ISRO is the Secretary Department of Space and he is the Chairman Space Commission. And see there each center is specialized in each vertical of space, and it has various autonomous bodies. Then InSpace came, which is attached to Department of Space. We are an autonomous body. After space activities bill comes, we will become completely autonomous. This is our organization structure where Chairman in Space is Dr. Pawan Goenka. He is advised by Chairman in Space Board. He is advised by InSpace Board. We have 3 directorate. Promotion directorate is at Bangalore ISRO headquarters. Our headquarters is at Ahmedabad. Program Management Authorization and Technical Directorate sits at Ahmedabad, along with Joint Secretary level IAS officer for Legal, Finance and Administration wing. And you see that Department of Space is also there, and Space Commission. Our chairman is the member of Space Commission. We get controlled till our space activities bill comes. To see that how Indian private companies are working, you see around 15 space objects they have already launched in a short span of 2-3 years. What all initiative we have done? You know, the government of India has carried out space sector reform in June 2020. Prior to this, in 2019, Defence Space Agency was formed and New Space India Limited was formed. Our office was inaugurated in June 2022 at Ahmedabad by Honorable Prime Minister of India. Within a short time of 8-9 months, we released the Indian space policy. Of course, work was going on on this policy for quite some time. And a very lucrative revised foreign direct investment policy. I will touch upon those slides. And space sector bill is being worked out. It can come anytime to the parliament. So this Indian space policy identifies the role of each actor. I have discussed about role of ISRO. In space, I have already discussed. New Space India Limited also discussed. Non-government entities can carry out any activity of building rockets, satellite, launching, owning, and operating space assets, including ground segment. They can do your data acquisition and dissemination. They can also own and operate orbital slots. So this is the foreign direct investment policy. Prior to space sector reform, FDI was only in satellite manufacturing and operations, that too through administrative rule. Now it has been made two rules. One is automatic rule. Directly you inform at RBI and in space and start working in space sector. 74% is automatic. Beyond that is also possible if the foreigner is bringing some advanced technology to the nation. Launch vehicle being a very strategic area, the cap is at 49% in automatic route. But beyond that also government, where it is likely to result in access to advanced technology or other regions to be recorded, that is administrative route. And manufacturing of components and subsystem, it is up to 100%. This is growing space ecosystem in the country. If you see, we have large companies around 50 plus, micro, small and medium enterprises of 450 plus. Startups are 310 presently. The number is increasing very rapidly. So these are the kind of space ecosystem which is became what all we did. So I will be very happy to tell you that Government of India has announced 1,000 crore venture capital first fund in July budget. We are operationalizing already. SIDBI is identified as a fund manager, and within a month's time it will be operationalized. Another fund is many technologies are at very nascent stage. Maybe TRL 3, 4, they are lying in the labs, in the colleges or any research center. But if any company wants to take it to TRL 7, 8, 9, 500 crore fund has been authorized for that. So up to 25 crore each company or academic institution who can take that bat and take this technology to the next level is most welcome. I have told about decadal vision, small satellite launch vehicle, 6 private companies are identified for an RFP has been issued to them. We have very unique scheme for students. That is pre-incubation entrepreneurship development. If you want to make your own company and you are having any idea in space, which you think that it is the novel idea, you can submit to any space. We will announce the second opportunity. First, we have already done. So this is pre-incubation entrepreneurship development program. It's a 3-stage program where you have to ideate, innovate, and demonstrate. You need not to come to any space or ISRO office. From backyard of your home, you can work on that with your faculty. You can work. Give that idea to us. We will fund it. To innovation phase, we will give you 2 lakh rupees. If you pass innovation phase, it will go to demonstration phase. We'll give you 10 lakh rupees and register your company. We'll help you register in your company. After that, you demonstrate it. Then you are eligible up to 1 crore seed fund scheme. And if you have done that seed funding, some level you can eligible for up to 500 crore technology adoption fund and VC fund. So starting from college up to making you entrepreneurship and successful entrepreneurship, there is the scheme by the Government of India. We are working with the state government for creation of manufacturing clusters. With Government of Tamil Nadu, we had already MOU and we are working with that. EO constellation is also being made in public-private partnership model. We are studying, a committee has been made by Chairman in Space and Secretary Mosby to study the contribution of space economy towards national GDP. We are taking the data for this. Very interesting requirement of private sector is the skilling. It's very important. We have designed 10 courses dedicated to the space domain. It is space tech in agriculture sector, fundamentals of orbital mechanics, attitude dynamics, essentials of satellite manufacturing, A to Z of satellite making in a 1 week. Experts from ISRO and academia are giving to the people. We have done a course on avionics and mission design for launch vehicle. Propulsion system, one dedicated course also we have done. And I'm sure in essentials of model rocketry, your team member would have participated when we carried out 1 week course with a demonstration at Air Force Station Jalali. Fundamentals of launch vehicle course is being planned on 27 April onwards. We have done a very unique course on space law, policy, economics and benefits. Around 500 plus people we have already trained, and 60 plus next batch is coming shortly. We will keep repeating them for the benefit of non-government entities and academia. These 1 week capsule courses are certified, or they are accredited by NSDC, Ministry of Skill Development and Entrepreneurship, and InSpace has been identified as a awarding and assessing body status by NSDC. As I've told, a national committee is formed for adoption of space tech education, which I am heading. Institutions are working with us, and around 1,200 students are already studying space technology in various ways, either single introductory course, bucket of courses, masters, BTech minor. I am very happy to tell you at IIT Madras was the first to start the introductory course, and tremendous response was got. IIT Roorkee has 200 registration for the introductory course. The cutoff was 40 there. We have also designed those people, those institutions, those who are working with us and adopting space technology, a 1 week immersion program we have planned for the student. They will go to our technical center and learn in a week's time what all is done in the space sector, starting from a designing to testing to integration, all aspects we expose them. This is received well. 2 we have conducted already, and more we'll plan in the future. We have already had approval for establishing Center of Excellence at academic institutions, those who are adopting space tech education in their curriculum. We are working on internship and placement opportunities for students. And I am sure MGR University students are well known. They are knowing all these competitions of CanSat and model rocketry competitions. So to see the effect of space sector reforms, if you see that how application we are getting, around 610 plus application we have got in a short span from across all, representing all startups, companies, academic institutions. So enthusiasm is growing. The investment, number of startups are growing. Investment is also growing slowly. The coming to digital vision and strategy, we being a nation of 140 crore people, our share in global space economy is just 2%, 8.4 billion, around that number. We aspire to go to $44 billion at a CAGR of 16%. It has some export component and domestic component. We have identified 8 verticals with Department of Space. This study was carried out where a lot of input came from ISRO. in each vertical of space, Earth observation, navigation, communication, etc., the percentage CAGR is also increasing. We are working to implement the space technology. It is a whole of the nation implementation approach where enablers are in space, DOS, ISRO. It is whole of the nation means we want to develop the space culture in the country where each one is the stakeholder, private sector, citizen resources, government resources. We have identified the 4 pillars with India's right to win space sector. With 4 pillars are build platform, create ecosystem, enable industry and international outreach. In international outreach also we provide opportunity to the private companies, to foreign companies and countries and we connect them. It is virtual or in person. 7 space days we have completed and we have been carrying the Indian companies. We are giving them opportunity to take to the International Astronautical Federation, IAC, International Congress to display their capabilities to the foreign countries and collaborate with them. So as a matter of fact, I will say that future is bright and you see this enthusiastic slide where ISRO is working on this technology. Government of India has already approved the Chandrayaan mission landing on Moon by 2040 and development of Bharatiya Antariksh Station by 2035. And to work within space, all of you can register at our website in space.gov.in. You will keep receiving the updates, what is happening in the space sector, what all competitions are coming, what are opportunities are coming, and even any application for facilitation and authorization. Thank you very much. With these words, I will stop. If you have any question, I can answer. Thank you.
Any queries from the attenders side? Any queries would you like to just ask with them, sir? Ask with sir? Sir, really it's an eye-opening session for us.
Yeah, yes, please.
Yes.
Okay. What is the weight of your satellite? When you okay, you can do it at our technical center also. Why to ISRO has a lot of work to do. You can take to our technical center. There are private companies also you can do in your backyard somewhere. So you can apply if you want to do. You can apply online to use our facilities at Ahmedabad. There are companies, those who are having for 1U and all, you can get in Bangalore in private companies also. Many places is available. You write to us, we will tell you where you want to do. This too small thing for ISRO to do. For bigger of 100, 300 kg, 500 kg, you can go to ISRO. We ourselves will tell, yes, now you can go to ISRO. Very good, no, it is start. Small is big, I appreciate that. At least now students are thinking of a new satellite making and all. Where it was 2-3 years back, nothing. So it's good. You write to us, we will 100% enable you, no issue. And we have a very unique scheme. We have a resident expert scheme where our experts, you just online, you go apply for our expert. They will guide you. And Sri Prakash Rao ji is there sitting. Dr. Prakash Rao is there with you. He is also satellite expert. So there is no problem from that side. So you have a lot of resources, starting from expertise to the testing facilities. What else you need, sir? Good time for space technology, space research in India. And I will tell one more thing at this time, which I have not added. Yesterday, we have very good discussion with the delegation from Italy. The space joint action plan in space is set by both the Prime Minister of India and Italy, and they have come with a very unique proposal to setting up labs, collaborating. We will work out the details and connect with MGR University also. If you are interested, let us know your interest. So there is a possibility of collaboration, sir. Great.
Any other questions from audience? Any other questions? Thank you, sir. Really, it's an eye-opening session for us. We could be able to know about, with your talk, space reforms in India, organizational structure, in-space initiatives, framework to encourage, special things about framework to encourage the private sector participation. And Indian space ecosystem, at last you have winded up with landing by 2040. Really, it was an inspirational moment for us to know, to hear your talk, sir. Thank you so much for your presentation today.
Thank you for the opportunity, madam, and namaste to all. Shall I leave now? Thank you, sir. Most welcome, sir, anytime. Thank you. Wow. Excellent. This is the rocket will go in competition or it's a future? Very nice. Excellent.
Thank you, sir. Thank you, sir.
Okay, sir. Bye.
Thank you so much, sir. மனமது செம்மையானால் மந்திரம் கூட ஜபிக்க தேவையில்லையாம் என்கிறது திருமூலம். விளக்கினை ஏற்றி வெளியை அறியும் நேரம் இது, for which we invite dignitaries to light குத்து விளக்கு. Thank you so much, sir. Better than 1,000 days of diligent study is the one day with a great teacher. We have a visionary with fountains of educational principles here. He is our Guru, Professor Dr. D. Vishwanathan Sir, Rector of our university. We invite him to deliver the welcome address.
அனைவருக்கும் எனது இதயம் கனிந்த வணக்கம். Distinguished chief guest of this morning, Dr. A. Rajarajan, Director, Satish Dhawan Space Center. Distinguished speakers for this day, Dr. Prakash Rao, Dr. Kalpana Arvind, Sri Kishore Ashok, Sri Vikram Sivaprakasam, HODs of Faculty of Engineering and Technology, distinguished teachers from other institutions, delegates from other institutions, dear students, ladies and gentlemen. I am very happy and proud to welcome our chief guest, Dr. Rajarajan. Very, very happy to say he is second time he is inaugurating our seminar. Our first seminar in 2023 was inaugurated by him. It was a great success, and further we had a second seminar. It was inaugurated by the Director of VSSC, Dr. Narayanan. Then he became the Chairman of ISRO. Presently he is the Chairman. I am sure that MGR's wishes to our Rajarajan to become the highest position after this inauguration. He was a director of Satish Dhawan Space Center. He was expert in composites and solid propulsion systems. Nearly 4 decades of service at ISRO, transformed launch infrastructure to support key ISRO missions, including Chandrayaan-3 and Aditya L1. He played a pivotal role enabling the launch of Vikram, yes, the first privately built Indian rocket. Sir, on behalf of MGR University and faculty and students, I welcome you, sir. Dr. Prakash Rao, yesterday he delivered an excellent lecture, and today also another interesting topic he is presenting us today. Sir, I welcome you, sir. Mrs. Kalpana Arvind, outstanding scientist of ISRO, and Associate Director, Leo's ISRO Pioneer, just retired, contributed to the development of sensor processing electronics for INSAT 2 series, part of more than 40 flown sensor packages for key missions, led the design and development of advanced sensors at Leo's ISRO. And he has spent 38 years of distinguished service to ISRO. Madam, I welcome you now. The other speakers, the afternoon, they are likely to arrive here. Mr. Kishore, CTO of Aero and Space Technology, and Vikram Sivaprakasam and KPIT Technologies will be coming. It is my distinct honor and privilege to welcome each one of you to this momentous national seminar, Space 4.0, Emerging Space Technologies and Innovations. Today, we gather at the Ramanujan Auditorium of our esteemed institution to explore the frontiers of space technology and its transformative potential for humanity. This event is not merely a seminar. It is a celebration of human ingenuity, scientific progress, and the relentless pursuit of knowledge that defines our shared journey into the cosmos. As we stand on the threshold of a new era in space exploration, we are reminded of the profound words of Vikram Sarabhai, the father of India's space program. There are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with the economically advanced nations in the exploration of the moon or the planets or the manned space flight. But we are convinced that if we are to play a meaningful role nationally and in the community of nations, We must be second to none in the application of advanced technologies to the real problems of man and society. Today, we convene under the banner of Space-4. We affirm the vision and expand upon it. Space-4 represents a paradigm shift in how we approach space exploration, a shift characterized by collaboration, inclusivity, sustainability, and innovation. It is an era where space is no longer the exclusive domain of a few nations, but a shared frontier for all of humanity. From startups developing small satellites to multinational efforts like the International Space Station, the democratization of space is transforming industries, economies, and societies worldwide. To the members of the Organizing Committee and the National Advisory Committee, I express my heartfelt appreciation for their meticulous planning and tireless efforts in bringing the seminar to fruition. Their hard work has enabled us to convene some of the brightest minds in the field of space science and technology under the one roof. Our India's vision. India has emerged as a formidable player in the global space arena. With achievements such as the Mars Orbiter mission, Mangalyaan, and the Chandrayaan lunar missions, India has demonstrated its capability to undertake complex and ambitious projects. Looking ahead, India aims to establish a permanent space station by 2035 and send astronauts to the moon by 2040. These goals underscore the nation's commitment to pursuing the boundaries of human knowledge and capability. Moreover, let us remember that space exploration is not just about reaching new frontiers, it is about improving life on Earth. Whether through the satellite-based healthcare solutions, precision agriculture, or climate monitoring, the benefits of space technologies are already transforming lives across the globe. As stewards of this knowledge, it is our responsibility to ensure that these advancements are accessible and equitable. Once again, I thank you all being here. Your presence adds immense value to this seminar, and I am confident that the discussions will be both enlightening and inspiring. Let us make this event a resounding success. Again, I welcome Space-4 emerging space technologies and innovations. May this seminar serve as a catalyst for innovation, collaboration, and progress. Together, let us chart a course for a bright future for India, for humanity, and for the universe beyond. Thank you. Nandri, Vanakkam.
Thank you so much, sir. Dear delegates, don't tell me sky is the limit when there is footprints on the moon, says a curious mind. Let's learn with space. It's time to honor our guest speakers with bouquet. Dear delegates, we are very aware of a hero from history, the King Rajarajan. Now on stage is a real hero from ISRO. Yes. We now invite our guest speaker, Sri A. Rajarajan sir, onto the dais to motivate our young children.
Yes. So we are very happy to have Rajarajan sir for today's presentation. He is a distinguished scientist, member of InSpace Board and Space Council Director, SDSC Sriharikota, Department of Space, Government of India. He is going to share his view in the title of Small is a New Big. Title itself is a very innovative title. Small satellites are revolutionizing space research by proving that impactful mission no longer require massive spacecraft. These compact, cost-effective systems enable faster development and deployment, making space more accessible to startups, universities, and emerging nations. Small sats are widely used for Earth observation, communication, weather monitoring, and scientific experiments. Their ability to operate in constellation allow for real-time global coverage and data collection. Miniaturization and modular design also foster rapid innovation and reduce mission risk. Agencies like ISRO and NASA are actively leveraging small sat platforms in their programs. Educational institutions now play a greater role in space mission, nurturing talent and driving research. Truly, in modern space science, small is powering some of the biggest changes. We welcome you, sir. The co-chair will introduce the today's speaker, Dr. A. Rajarajan, sir.
Shri A. Rajarajan currently serves as the director of the Satish Dhawan Space Center, SHAR, India's premier launch base at Sriharihota, and is a member of the InSpace Board and the Space Council. An expert in composites and solid propulsion systems, he has been a key figure in India's journey towards self-reliance in space technology. With nearly 4 decades of service at ISRO, including senior leadership roles at Vikram Sarabhai Space Center, he has contributed immensely to the design and development of launch vehicles and spacecraft composite systems, pioneering advanced materials like carbon-carbon composites. He also spearheaded the establishment of a technology center of excellence for composites and helped form a dedicated space ordnance entity at VSSC. As director of SDSC SHAR, Shri Rajarajan has transformed the launch infrastructure to support ISRO's flagship mission, including Chandrayaan-3, Aditya L1, the Human Space Program, SSLV, and the LVM-3-M2 OneWeb India 1 commercial mission. He played a pivotal role in enabling the launch of Vikram S, the first privately built Indian rocket, symbolizing a new era in India's space sector. Under his leadership, SHAR has been equipped to handle concurrent requirements of both ISRO and private entities in line with the new space policy, including the development of an exclusive launch complex for small satellite launch vehicles. His strategic planning during the COVID-19 disruption led to significant innovation and optimization. Notably, in early 2023, under his direction, ISRO launched 4 different types of launch vehicles within 4 months, setting a record. As chairman of the Launch Authorization Board, he was instrumental in the success of Chandrayaan-3, overseeing critical test and launch campaigns. He has been a strong proponent of industry collaboration, playing a central role in outsourcing composite manufacturing and solid rocket motor production to Indian industries, fostering indigenization and industrial partnerships. Currently serving as president of ISAMPE since November 2023. He holds several international publications, a patent in film boiling CV1 technology, and has received numerous accolades, including the ISRO Merit Award, Team Excellence Awards, and an honorary doctorate from Satyabama University for his outstanding contributions to space applications. Thank you, sir. We welcome you.
First of all, I would like to know how many people understand Tamil? Oh, huge. Okay, good. Last time, the feedback in 23 was I was going extrovert on English, and some people told some of the effectiveness can be used with some punch lines to do it. Okay. Thanks for the introduction, ma'am. And I'm always grateful to Professor Rajarajan sir because he's a doyen in our system in many areas. And most, at least 10% of his enthusiasm I have to show here, right? Otherwise, we can't go and do it. And that is the spirit. Actually, to be frank, I was not in a position to come today. I'm supposed to be at Madurai and then Vijayawada. But chairman had decided to, my chairman decided to come yesterday. And I requested him to relieve me to come to Bangalore. So, first of all, thanks to my chairman, Dr. Narayanan. He completed the review yesterday by night 1:45. And he relieved me so that I can cancel my ticket and I'm here. And I promised Dr. Vishwanath that I will be here. And Kavita ma'am also. She's really pursuing. So thanks to me. Actually, week. Touch up. Okay. So, before going, we will go into some philosophy. Sir told me to talk about small is big. That's another topic which I gave 2 years back. Today, even now it's very relevant, but I thought I will keep it for a specific audience as and when Dr.M.G.R. University calls me and gives me an opportunity. That I will try to, because every time repeating at the same hall, for me also it will not give me the energy. That's why I thought I will at least do something. The today's relevant is development, right? Valarchi. But any technology today, any technology is welcome. That's how we go. But now the new coin ways come, sustainability, right? Now the phrase word is wherever you go, next 4 years ago, it is going to be sustainability. How do you going to sustain this technology? How do you going to do a new way of doing things? People used to come, you are eating morning onwards, idli, dosa, all are okay at this place. Suddenly somebody told, what is the best? Suddenly somebody will come. How do you, these are all technology, techniques of trying to catch you. Eating oats is the only way for you to live, otherwise you will die. Tomorrow if you eat, go on, rice, eat as if you will finish off. But people are living for 2,000 years or millenniums. But they are able to sell it, the idea. There is an idea. There is something advantage which you are showing, something not there is people are showing. But it's good. So the perception is, the key is perception. The ability to observe what it has been put in place and the way you need to synthesize all those data and take a decision on your own. And that is what is the essence. And now the sustainability comes into the picture just because of that. Can you sustain whatever you are trying to do? And is it good for you, for the community and the society at world at large? And this is where. But the fundamental question again is human being ourselves. Who are we? Where from we came? Where we are going to? There are 3 fundamental questions for any living thing in this world. Or if that, for that matter, anything in this universe, anything in any other universe, whatever it is called. If there is a living organism, it should have 3 fundamental. Enge irukom, enge irundu vandom, enge pogirom. At this instant, you can talk with certainty that you can tell that we don't know, right? We don't know the reality from the perspective of time, the yuga or whatever we call, where we are. It's fundamentally not possible to say where we are and where from we came. So the scientific temper of you, either in theoretical physics or chemistry or whatever you do, or the practical things, the technology, or what you are going to do, all is to search for this fundamental answer of these 3 questions of a human being. Whether we are like this 10,000 years ago or millions of years ago. Now, we are, as a human being, we have developed one trait. That is, as one of the species of living species in this world, we are the most greediest. No doubt about it. No doubt about it. Selfish, every living thing is a selfish. There's no doubt of it. Even a born kid will try to grab things, and there is nothing called giving away. But that is the natural part of it. Don't think what this fellow is coming and trying to talk. Sir has called him to talk something else, and he is giving some philosophy. I just want to give the essence of sustainability and how do we go about it. So whatever you do today is very relevant. There's no doubt about it, because you are living in the present. Why I am putting it in this perspective, as you go, you have to develop your horizon in a much, much higher plane and look at it much beyond your domain. What does we do about our planetary system? Is anything we know beyond Pluto? Even whether we know Pluto? There is a question going on whether Pluto is a planet or not, whether it is going around sun or not. And our whatever you call it as astrology, astronomy, all those things, cards of square, zodiac signs, gives in circle. Many people try to learn in many ways, but all has some relevance. My latest hobby is in the Indian knowledge system of how we adapt and how we lost it and how we have to regain that. That is a different story altogether. But all these things finally comes to sustainability. How do you improve one's life and gather knowledge and further and further? So with that topic, today I will just spend some half an hour, not more than that, on whatever I'm going to present, you all know directly or indirectly in some way or other. Nothing new I'm going to present. I'm only trying to open up some perception of where we stand in this place. So, some of the many technologies, as the world space technology, when the exploration started, it all started as a Cold War. You all know that. After the World War II, the rocketry, going to moon was the time. At that time, there is a pioneer, Dr. Vikram Sarabhai, who in VSSC, at a very nation told that we are going to develop space technology for the application. We are one of the first countries to do that. We can do it for application. That is for societal need. And we have continued to do this. Only after that, people have started doing technology development. Otherwise, it is a race between the super might, who is the mightiest, and how well we are of going to the moon and coming back, all the other planets. Nothing like dream, like going to another celestial body and go and land. Because so far you are always called as Bhumi Vasi. Somewhere you have to move Chandra Vasi, Chavai Vasi, Shukran Vasi. Kotrame Matano. Bhumi Kotra, all planetary system we have to do. So, for this, you should have some technology with sustainability. So, I used to put this slide everywhere for the young students, especially. The space is nothing but a scientific pursuit for application with a lot of common sense and only a small grain of salt like of engineering. Don't start applying engineering in a heavy way. There is nothing like it. Lot of things are common sense. It's your life, and how do you do? And that is space for you. And here, when you do this, if you apply the common logic and the thoroughness and the rational, and that's what space technology is. I used to say thousands of small things. What is so big in rocket? What it is? Why it is so difficult, people tell. I'd say the rocket is nothing but thousands of technology, or I'll put thousands of small things, which you all know, all are Newton's law. There's not big new laws and all, they are not going to bring and invent here. Everything is known. All those things has to happen in a synchronized time, in a sequential manner, without delay, without even delay of 20 milliseconds. That's the only problem. Thousands of small things has to be done in a precise way, and that is rocket technology, nothing else. But how to do it? Many people tell. People tell artificial intelligence, whether it is going to change. Please, my dear friends, I am telling you, artificial intelligence is there in the rocket and satellite for last 60 years. You know how satellite is there for 15 years in space by doing its own corrections and control and sitting there? There is a brain put there, which is trying to do based on the data provided. And once in a while, we'll send some patches. Like you go for suddenly some training, no? Okay, do this training, do this course corrections, do some skill development. Like that, satellite will do some patches. Okay, with this knowledge, it will correct itself. Launch vehicle, it is accelerating at a huge speed of 3G, 4G, 5G, and reaching at 9 kilometers per second speed. Right? 9 kilometers per second. It is mind-boggling, around 27,000 kilometers per hour. 0 to 100 kilometers in the highway itself, you will find it going very speed. When that kind of speed, the control system, everything has to be precise, and it has to act on its own. There's no point in a manual intervention. The computer and the closed guidance and everything has to take over and do it, and put an orbit in a precise orbit. Otherwise, you will be somewhere in the universe, somewhere in the planetary system. So, a computer is doing all this with its own intelligence, its own data collection. Today, Kalpana madam will tell how the sensor is going to tell how accurately it is going to point out. The madam will always come with some accuracy. We will say one more order we have to bring it down so that we have to be accurate in the space universe. Dil mangte hai more. Sorry for you. Right? Always we want more. The camera, if you go 64 GB, 48 MB capability, file size, if you take a shot, people want and buy. I used to ask him, have you ever thought of that? What is the size that photo is when you take the size of that file? 48 MB, you can't even transfer that photo to anybody. What is the point in having such a thing? So you have to be very careful. So that is where I'm trying to go here and there only to impress upon you the sustainability is a very big mark. The best you can always develop, but whether it is the one you want. I can go and get a Fold 5 generation is that 1.5 lakhs Samsung phone, iPhone Pro 6. But the camera it can take, they tell so much advertise, but nobody thinks whether that kind of quality is good. Just a 2 MB, a 3 MB pixels enough to take a print. That's enough. How many people knows this? We go beyond something. That's where the sustainability picture comes into point. So when you try to do all this, we also understand you as a human being, you are also applying lots of logic in a sequential manner, never in parallel. Okay? Human brain, if you talk to a doctor or talk to a, they'll say, the brain actually processes many things in sequence. Many things in a sequence. Never hundreds of things at a time. You may think so. And the time taken is not even a millisecond for each thought process. And that's 1% of that process if you bring in, you have one of the best, world's best artificial computer or whatever artificial intelligence in place. That's how you have to see the perception. Now we'll go into the subject. So in ISRO, in the space activity, there are 5 major domains. Not only ISRO, which was doing, now you would have heard Dr. Vinod-Kumar talking about in-space activity of the space reform. Each and every one, academia, industry, startup, anybody can look into this, provided you are within the scheme of things. So we have space transportation, where you have to go from one place to another place, nothing but transport, bus, lorry, car, vehicle transport. So launch vehicle, rocket is nothing but a space transport to take your asset from one place to other. The space infrastructure is nothing but satellites, which is there in space and giving you a lot of data. And sometimes it will be a space station also, where you can go and live. Now, the application is the app. You will say, no, all your mobiles having a lot of apps. You know how many apps? Today I'm going to talk about only apps. Satellite having a lot of apps. And that apps, how it changes your everyday's life. Each and every moment of your life. If a satellite is put for 5 minutes, nobody will have money transaction. I can assure you. You are done, stuck. A strategic sector will just collapse. Ships will stay where it is. Aircraft cannot land. That is the power of all those apps placed at satellite, which is doing this data dissemination. And that is where the space application, where we do a lot of application. And the entire business, almost 95% of the business is in space application. And the capacity building. You cannot do anything without a capacity, right? If an aircraft has to land, you can build the best aircraft. But if you don't have a proper airport, you cannot land. Range system. You know what are the things going behind an airport? Anybody knows? What is cost of an airport? Not the landing strip alone. Landing strip is the cheapest one. You know what is that? Instrumentations. Communication, radar. In space, you have only one road, highway, 2-3 roads. There are multiple ways can approach. You should not hit each other. The ways it has to be transformed. And they are coming at a very high speed, 300 meters per second, something like that. Or finally it comes to 65 meters, then 40 meters per second. At that time, you should not collide. The air that it will give you a drag should not create a problem. So this is called air traffic control, which is the costliest one. And with instrumentation system, inertial landing system, automatic. So that are the costliest things. And that's what we are doing at Sriharikota every year, day in, day out, innovations, how to reduce this cost. To keep a rocket ready for a launch, we spent more than twice that of rockets cost in the range to do this going. And that's where the things are beautiful innovations are coming, which is not seen in the public domain, but it's applied indirectly on you. And that is capacity building has to be there to make all that. Then the human space. Once the human factor comes into the picture, the entire scenario, the game, the canvas changes. The safety aspect. Yeah, at any given time, you have to bring the human safely back to the earth. And he has to be provided for. He or she has to be provided for. And that means the suit, whatever oxygen, whatever water that you take it for granted here is not available there. And you are not protected from UV rays also. Earth is having a protective environment. That's why life is possible here. Same protective environment, you have to bring it artificially. How do you do that? That's why the costliest technology is the suit when you go to space. It has to remove the moisture from your body, keep it same arch, the oxygen supply, the pressure, everything else. So that is the one includes in the human place in the space. Now, how do we go about this? So it all depends upon what is the market. The market is the need, strategic need, the commercial, theoretical, and the aspiration. That we also should not be second to none. We also should develop our own technologies. If I want, okay, we are a poor country, we don't want to do anything, you want to do only farming and trying to sustain yourself, people will start gaining upper hand. When we are ready to move to another planet or this, you should have your own technology. Then only you can sit in the negotiating tables, sit across people, right? When we discuss with friends, they want to take you only when you are all equals, right? Nobody is going to take some unequal ones and asking to bring it to the same table. For you to be relevant, you have to develop technologies and be there in that place. I will discuss all those things. So, considering all those markets, then we have to see the global trend. Then the disruptive technologies, is there anything possible that is on the horizon? You have to look forward. That's what your professors will do, some lot of library work and lot of literature survey to look for what is going to happen, what are the people, other people are doing the same. You know what you're doing, how relevant in the today's world, and who are all the competing technology that's going to come, and how we stand here. You should know the disruptive technology, because somebody you asked to put in some 1 crore or 20 crores, and then suddenly say this technology is not viable after 3 years. They will leave you. So the disruptiveness should be known. All those things, the academia is an important ingredient where huge resources of knowledge is put in different ways. How to tap it. Then there is an ISRO type of organization that we are there, part of government and academia. We put together and put up the proposal joint to the government, get the clearance, and that's how we are going to do a lot of applications that I showed in the right side of the screen. Many of these things. We will see one by one. Now, before going there, we should know where we are. Our 64% of Indian land is agricultural land. and a dry area. That's the problem. We are the one of the country which is having the highest rainfall in the world, the best of the rivers. Everything is available. Everywhere told rainfall highest India. You know this? And we are built with such an ecosystem naturally that we don't require any protective system to live. Please understand, I am talking about it from the biological point of view only. India is the only country which doesn't have killer insects like South America or like this. Weather is so moderate, 30, you think this 40 is very high, but it's not so. It is actually good for human, the way in which it is good. You don't require a protective system, and I am saying biologically you don't require even a cloth to live. You can live. Life is possible. Go to any other place, you require lot of clothing, lot of protective system. South America, same similar climate, but it requires lot of protective ointment, everything, herbs, chemicals to protect you from insects. Lot of bacterial infection. You know yellow fever? Whenever I go to South America, you have to take an yellow fever injection. Without that, you cannot go. India, nothing is required. Chalo. No problem. You can do it very well. Nothing to worry. Nothing is going to happen. I am talking about life. So, but in spite of that, I am told all this positiveness, in spite of that, 64% of the agricultural land is under dry area. That's the problem. And we have 1.4 billion. This is 4 months back, last year, December, this one, 1.4 billion. Second largest country in the 3.28 million, seventh largest. Then we have 65% of the population depending on agriculture, and it is providing only 20% of the GDP. I am just trying to, you are all now crossing from teenage, you are going to enter the world after 3 years. You should know all these realities. Forest, one of the best forest covers. The water resource available. Water is available in plenty in some areas, not at all available in the areas. That I don't have to hear. I'm not getting into geopolitical issues or politics. This is the problem where we have to sustain this. Now the major issues, right? The challenge is, I'm not able to read here, so I'll read from here. The challenge is the per capita agricultural land is declining. The diversity and inequality, everything is increasing there. Okay. The resources and the scale. Now, one of the important, that right side, this is a satellite image where you have put. The 54% of India is facing an extremely high water stress. That's what I want to bring. Now, next month, it is going to be one of the whole entire administration has to work to take care of this. And a very low per capita income. Everything is available. In a big scale, we are one of the best. But coming to this one, we are not able to translate into this one. So, as the days goes, the productivity in dry land, the same way of cultivation is not going to help. And also the monsoon is order of the day because of the green gas increase. You know the green gas is a must for a living organism. How many people knows this? Without green gas, to some amount green gas is required. But once it's getting heated up beyond a point, it becomes a problem for us. And it is a fact that the earth is getting warmed up. Now all those we are doing is only to reduce the rate of increase of heating up. Not that reducing the temperature. We are only working on technology which we are looking at to reduce the rate of increase of heating in the world. So that at least we can have the human being. Before that you have to find place to live. Like Chava, Buddhan, Mars, Chukra and Karat, moon, how to live in moon, how to live in space. All going to be reality. We will discuss that. So this is the your job is put a satellite through MGR University and develop apps. You all like apps, right? Mobile alla app venum illaya. Right? Who doesn't like apps in mobile? talked in the negative way. So, since you like everybody likes apps in their mobile phones, now you have to show that you develop apps for satellite and make society live. So that is what I am trying to come. Now, first we'll do the urban sustainability. What and all you want? We will not make any food, but we live in city, we want food, we want water, we want everything, but we will not make any of these things. Right? So how do we do that? So, one of the biggest products, yes, you can do it. I'm not joking. I told in a negative way, but the point is here is the food sustainability. How do you develop? There are theories, I will put it like this. So, the crop production forecast, I written that, very important. I will put it like this, my dear friends. No problem, no problem. Now, one important point, I will put it like this. Today, in your Tamil Nadu or somewhere, we will take, just somewhere. They are having 50 acres, we will take it. And she is putting a crop. After putting the crop, it has to go to the block, Tahsildar, Sub-Tahsil, Tahsildar, block. Then it has to go to the, that is called division office. From there, what he has put for crop, finally go to sub-collector. One sub-collector will be there who is identified for all this one. And he will collect, he or she will collect. Then from the district, it goes to the state, collate. Then it goes to the central resources where what it is put. It will take minimum 2 months. From there, again it will come down. If this is the number of capacity of crop put, and this is expected yield, no? For under 50 acres, there is a expected yield. So let this go to this, go down. Understood? Put grain go down, because it has to go and they have to distribute. After 3 months, by this time crop will be over, everything will be over. He will be waiting which go down it has to go. From that go down, they will decide which place it has to go. This is how we are living. Now I am telling the imaging of satellite imaging, both through hyperspectral thermal imaging and other aspects. I know develop an app for last few years, how it was cultivated, what was the yield, and based on the greenery and grills and the RF reflectance, we can always get a feel what kind of cultivation, what kind of yield it is going to give. 15th day we are reaching to the place who has to take the decision making, what kind of food grains is being made, where it should be distributed based on the simplex method. Third year in engineering, you will be in mathematics, you will be studying this. Now, how to distribute multiple resources, multiple demand, from one resources to one demand, to reaching cost, and this will be distributed in a method very easily. Now we are telling, I ingrain this also into the app of satellite images and this one, and every 15th day update will be there. The field is going well, going on, improving. So this food grain has to go to the, from Vidipur, it need not go to Vidipur, it can go to Trichapur. It's over. The farmer knows what he has to do. The government knows what kind of yield is going to get. Everybody is prepared for the real-time decision making. Earlier, this decision making is 9 months, and 30% of the food grain will go to the waste. Now we are doing. Is it a good app or not? So will you do this app or not? So all CSC computer science only do this. So there is one. I am trying to give one example. Try to keep you focused. What kind of technology that is going to be possible? How to make it efficient? People will start trying. Middlemen will go. All those things. But we, as a technologist, we are not worried. We are trying to provide an input in real time. When the rain has come, we don't know what the damage happened. Why? Apps are available. Whether crop is damaged or not, we can always make it out. We have synthesis, sample making by drone, and this one will make a sample, and imagery we can reproduce and correlate and know what it is. Nothing is required. We know what it is going to happen. This is one simplest task, improve your capability in entire India. So each state can have its own satellite and revisit the food corporation. So, next one is urban sustainability. You have bought a land, kept it some place, you are not at all visiting there. And I can go and do something or that. Somebody is encroaching or not. Satellite image will give you the way, the encroachment. Peg marks you can keep, which will give the sensor back. You have to pay for a price. So, without anybody, you can keep your place safe with peg marks, with sensors. You develop small sensors. I'll keep it at the boundary, and it let it reflect. And a cost. You have to pay a cost, no? Otherwise, you have to put a security guard, and he will sleep there. Whether it is going out there, nobody will know. Now, I am giving this. Just imagine. I am just trying to poke your mind for this. What it can do. This one. Then the water resources. Mundila அப்படியே இது வச்சு இங்க தான் தண்ணி இங்க கிணறு தோண்டும்பாங்க இல்லையா முந்திலாம். There are some experienced people who knows where the water is. Now 50 meters below the ground also we can, looking at the moisture and the capillary action of the soil, we can find out where the water resource is there. And in that land alone you put the watershed. This is one, the water sustainability. Then comes the environmental protection. You know, windmills and all you would have seen that we have 10 years of map, and in Sriharikota I have 50 years of map of wind pattern. So if you have a very good land in some place, which direction I have to put window? I will give you a direction. Put the windows in this place. 9 months in a year, wind is coming in this direction only, put it. I can do this. So these are the other things which I want to do. Then the disaster management, which is a success story in India. Entire cyclone, we are able to predict 15 days before or 20 days before how it is gathering. That's why we are never seeing one loss of life or loss of cattle life in entire cyclone in the last 10 to 15 years. You would have seen this. And we are doing it thanks to Prakash Rao and Kalpana Arvind sensor and all those things. So many other things are working here, which is providing the data, weather data, which we can predict the movement of cyclone and this one. But what it will damage the resource, we can't do anything. But we can take preventive action. That is where the disaster management, because India is a country which is always devastated. So this is the one thing. Then the forest cover, whether forest is increasing or decreasing. I have proved that in Sriharikota, we in the last 4 years, our Prakash Chavan, our NRC director proved that we have densified the forest by 3 times. That is, jungle cover is increasing or not. That also we can cover. This is one of the aspects which you have to look at it. So, all those things which I have put it in like this is what pre-harvest estimation. 5 apps are there. Pre-crop forecast, grain, stack management. Then the wasteland. Which are the things can be converted to an agricultural land or arid land. These are the I have put estimate, wasteland, crop inventory, and any rain comes, whether what you have to do with that crop. You have to go for early harvest or not, all those things. Like before it comes to ready, 1.5 months before we are giving this estimate, for a government to take a call, for you to take a decision in a private way. How well it is, right? Is it not good? You need not wait up to January 10th to know whether you are get a good harvest or not. So next is the energy security. Wherever wind flow is there in the ocean, I put the windmills. You estimate where the solar intensity is highest, you put solar panels. You imagine, these are the things which we are doing. Simply putting solar panel, I am not getting power, it means you are not put in the proper place. Intensity of light, the duration over a period of duration without cloud cover, how much you are getting. That's a very important aspect in this. Any polluting environment like dust forming onto solar panels. So that also you have to see. Then the wind energy, mean wind speed, all this. If you go to an app in NRC Google, Bhuvan it is there, no? Yeah. It is available. People can see, and you can develop an app with that data and put it in space and sell it. Make a business model out of it. That's what I am trying to say. Be an entrepreneur. I am going to say, but I started now telling now itself. We all have to become an entrepreneur. You have to think, I am an entrepreneur. What do you do? You do this, each one of you, country will go in some level, some capacity, right? That's what I'm doing. It's not only job or what I'm doing for. You become an entrepreneur with your own ideas how to do this. At least for 2 years as a startup. Some will click, some will not click, but the experience that you went through it can never be taken away from you. That's what I'm used to tell. Okay? So next is the methane gas development of the wherever decaying things are put. We can manage and try to identify those places. Like that I have written some of this one assessment and vegetation. And which are the vegetation type? Based on the soil content and reflectance, we can find out what kind of soil it is and what kind of crop we can put in that place. Worst case, which you have landslide, also the pictures we are trying to find out real time. Now the only thing is how to predict an earthquake and other things, which is an important aspect with lot of sensors in place at the ground, along with the temperature and other aspects. We have to look at it, how to develop a mechanism to predict all those natural calamities and India has done a wonderful job in this area. No doubt about it. And we are trying to improve this further and further. Then the air quality monitoring. The map that I am showing in the image is the air quality map. With this, we can find out predicting where the air quality is going to go bad or not and what you have to do. And this is one of the app. Then the tele-education through industry. We can't reach it entire place. You would have seen online education. Now through each year, I can sit here and teach. Last year, 2023, sitting at Anna University, I reached out to 900 engineering colleges at a time. For 4 hours, I had interaction. It was a beautiful experience for me. Because I know that this technology is possible, but experience in the real time as a user is also you should go through it. You will be connected to all your fellow engineers everywhere in the real time and crossing the information flow. And that's one of the information I am seeing the resultant not only of education, it's a two-way communication. That's what is possible. The bandwidth, everything is now increasing. So tele-education is one of the best Indian. We are the pioneers to start with. Now everybody has started doing this. Then telemedicine. Just imagine what you want. Why you want to see a doctor? Nowadays every diagnostic tools are available. Even my phone gives everything, whether my imminent heart attack is coming or not, like this, right? Everybody puts this app. Now imagine, you require to see a doctor only if somebody is required to put a stethoscope or a BP. These are two important things which is required to be done. The rest of the things, everybody else thinks. So yes, standard, your friendly doctor is alone is enough by your side. The specialist can sit anywhere. Just imagine. Specialist can sit anywhere. And the only friendly doctor is required to do BP monitoring, other things, other vital symptoms. That also now we're going to do by monitoring. Once we can monitor from 36,000 kilometers, 400 kilometers away, monitor the surface and find out. We can do a scanning and find out what you want. And synthesize each portion. And diagnostic tools are already available. Many things are being captured by the robotics and other tools. Now doctor has to give the expert opinion. The radiology itself is going into a treatment radiologist, not the simple radiologist signing. So imagine, engineering has gone in a long way to help the medical profession. The best one is a stethoscope. Without stethoscope, the way in which the diagnosis is being done in medical world was changed drastically by the stethoscope, which was invented many, many centuries ago. But that is what the beauty of engineering skills and instrument formation. So that you do with telemedicine, many things is possible, especially we in remote places in Sriharikota. Now, India is a large country, tracking marine. We have a 7,000 kilometers of coastal line. Monitoring entire thing is very, very difficult. So we developed the NAVIC technology. So using our aperture radar and other things, synthetic aperture radar and aspects, we can monitor the surface, and with the NAVIC, we can find out where you are. You know, mobile phone. You go to the shop, pay some money and take the mobile phone in your hand. I am guaranteeing your privacy is gone. Right? If there is an app in this world to say within 5% error, how many people are there in this room without contacting anybody, without seeing anybody? Do you know this? And a technology is being developed to target not the room, target that one individual with one particular place. That also is possible, triangulating all your instruments without you knowing. This is also possible. So imagine the apps that is being done. You go to T Nagar, go in front of a shop, just don't do anything. Wait for 3 hours, simply there. Then go out. You will see ads. Whenever you go to social media, you will get ad related to the shops in front of in which you stood. You will be mesmerized by the way in which the data processing is being happening. And you are saying AI will kill us or not. AI is already there to do all these things. Right? You need not do all these things. That apps are all over. Now I am coming. How to do it useful way? Useful means all are useful. All are marketing. All are business. Now I want to know from here, the famous bus number is 23C and many routes in Chennai. How many people knows the bus routes of Chennai? Numbers? There's a simple R. I am never from Chennai, but I know the famous bus routes. It's a number system. That is the beauty of the system. Okay, now I'll tell you what it is. It's called tracking system, NAVIC. We should have our own NAVIC system. Earth is rotating at a very high speed, right? That, when you put it, when you distinguish between 100 meter accuracy I want to bring, navigation, like GPS, India is having an accurate NAVIC, where we have to land aircraft or helicopter in whichever place we want, at the accurate portion, without any pilot's requirement. You have seen driverless vehicle, no? I am talking about driverless or pilotless aircraft landing. And some of the things which are going to come is, now I am telling a Delhi route. We will take it as Chennai. One of the busiest route is Maduravoyal to Tambaram route on straight road. The way in which it goes, where and all traffic, the buses is going slow, where it is going fast, in what way it can cover, how many people are entered, all those if you monitor, you can work out a very cost-effective route methods and timings. And this is what we are trying to do in one of the things. And the next one is Nariman Point, where from the gateway of India, the boat has gone and come to make sure that whether it has crossed international border or not, how much time it taken, what are the deviations it could. The entire mapping is available. Now, are you convinced that if your parents or if anybody wants, where you went, I can precisely monitor within 10 meter accuracy, whichever places you visited. You believe? You have to believe it is possible. Okay, this is the app, one of the best methods to see strategically, economically, to work out bus routes and so on. It is why it is required is to make sure that our fishermen doesn't cross international border, and also where the fish is available, there to go. So one of the best ways is railway crossing. We have more than 50,000 railway crossing, unmanned railway crossing. We cannot put anything, it will become waste. Everybody will steal it away, stole it. Because for us, even iron is still an important commodity in India. The costliest instrument they will not bother, but iron is there, that will go away. So the barriers will not work. So we are developing an app. It is our former chairman vision in the government of India's, this one, Kiran Kumar Sar's vision that using NAVIC, 2 kilometers from the railway crossing, the train will know its location and to start giving a low beep. The natural sound will come increasing when it reaches 1 kilometer, so that the people who are crossing the railway crossing will be aware a train is coming at a high speed based on this. So these are the things which you have developed. Many places it has been developed in a much better way. So this is what I am trying to do this, and the satellite will give the real-time data of all this position, and the horn in the railway crossing line will start hooting what it is. Now, coming to the international cooperation, if you do it alone, will not help. you should go and reach out to the fellow people who are doing the same technology, because that makes the economic sense. Then you have to become a partners in progress. You know the costliest satellite that ever made by human being, ISRO, is going to be launched in another 2 months' time. It is made between USA and India. We are partners. 60 years back, we got help from them to make a small rocket, Niki Apache. Today, we are sitting along with them, developing 2 payloads to develop the entire tropical areas of minerals, resources, weather condition, and the costliest satellite ever built in the world. 950 million, right? 950 million. And that is the one going to go in 2 and 3 months. And that's how the partnership should come through. You should be equal. So you have to develop your technology for that. And the space diplomacy. Space can be used for war also. Don't ever doubt. Space is an ingredient part in the every system in military and strategic part. Because you are keeping your asset offensive weapons in space and then come and hit. So nobody can go and touch that. And that's how people are trying to use. And that's the long-term sustainability. How do you sustain this in the long term? Keep it. Because space is the only place where you are not polluting anything. And the big space to do it. So in conclusion, looking forward, we should have satellites with higher throughput, or multiple capability, or small satellite with specific applications. Then the space-based multimedia and broadband application. That's what we call as big data. Next line is precision forecasting. India is such a vast tropical country, you have to start having a precision forecasting. The satellite broadband so that you can have 1 TB data transfer. And we have to make a smart cities, which has to sustain by itself with the resources. And access on demand. Whenever I want an access on demand, that should be the way to go through. And the digital India, please understand, today the maximum record human being in space is 17 or 19. I am not sure, 17 or 19. Now it is 12. Another 50 years of time, I can guarantee you that, or another 100 years, there will be at least minimum 1 lakh or 1 million people living in space. Just imagine, I want a bio bubble with a Kevlar fabric with a polyimide thing which will effectively monitor, filter out the UV rays. 100 meters by 50 meters, or 100 meters by 100 meters space bubble, where everything is available. You have your own farmland, crop, because water, everything, recycling possibility, technology will come into picture. Once in a while, you can come on holidays to Earth and see some places, because you would have ruined the Earth already by that time, because it warmed up like anything. Then you go back, sustain it, and a delivery system, because solar power is available, huge power resource available. So how do you reinvent cycling? It's going to be a reality. 180 years ago, Gandhiji took 6 months to go from Mumbai to London for the first roundtable conference. So, down the line, it took only 6 hours. We are now taking 9 months to go to Mars. We are working out how to do it in 45 days or 60 days. See, the human civilization can improve only if everything can be done by robotics and missionaries, no doubt. But only by spreading the human across planets, you can sustain the civilization and the humanity along this one. This is what Hawking's famous quotes. How many people have heard about Hawking? Have you read the books? Read. It is 100 years ahead of his time, at least. That is how it is. And then Michael Clark. That also an interesting book who settled in Sri Lanka. These are the things which you have to see how we do sustain the human. Finally, you are doing all this to sustain a human being in this world for another 1 millennium of years. That is what we are actually aiming for. And that's what you have to do. So with this, I conclude and try to exploit the renewable energy as maximum as possible for a very good sustainability. So, in conclusion, thank you for listening. Sometimes it is boring, I know this, but I thought I'll take this subject to talk about a young audience, which they will feel that what they are looking for. Thanks for listening. Thank you very much. Any questions? Okay for me.
Thank you so much for your excellent presentation, sir. Actually, you started with the way where we stand, but you made us to understand where we stand. Thank you very much for the one. Queries from audience side? Yes.
Anything under the sun is okay.
Sir, myself Pranab Kumar from BTech IT. I'm part of Dr.M.G.R. Space Technology Center. So actually, from your, I would like to ask you, from your perspective, what critical skills and knowledge should you think that a student should develop to enter into the space sector for the current age?
The best job in space today is space law.
Okay, sir.
Wherever law is there, those who know law are the best people, right? They will understand everything.
Yes.
Why? By studying law, you will understand all the rules and regulations of the entire world, of the entire country. And you will like to know a big perspective. I am just talking in another term. But skill-wise, the most important aspect is you should be expert in at least one or two areas. Jack of all trades will not hold good anymore. People are talking about all jack of all trades is not, henceforth will not hold good. That is, 20 years back it's good. Our time is okay. Now you have to be expert in, you have to bring to the table one expertise minimum. And it can be even financials. I told about now food, how to deliver the food in real time. You know, Swiggy is a success story based on, they worked on one of the best delivery system, the most cost-effective delivery system they worked on. They reduced that overhead, almost brought to 2%. So the skill set can be in many ways. So in your 20, 30 subjects, you see that I am the expert in this one particular skill. That itself will take you to anything. It doesn't mean that you have to be in IT. There are sufficient skill set you will develop on your own. But it can be mechanical engineering, or it can be a computer programming, or it can be a, what you call, power supply, harnessing the power supply. The electrical power supply, how well I will harness without getting heating up the equipment. That is another skill set which has to be taught developing. Then the mechanical, structural, mineral, materials development. India is a very poor in materials science development. It was once upon a time very good. But now, because India perennially, civilization-wise, we are so good in material science. Otherwise, so many statues and concepts would not have come in this place. But what you have to develop is how to develop the fundamental research and go further in other electronics and other things. Not only application, but other areas. So I will say the semiconductor, developing a material, cost-effective way of putting the semiconductor is the next best thing. Then sustaining it in a minimum power. That is, only you have to use minimum power. And that power, if it can come through some renewable source, best, nothing like that.
Sir, I have one more question. So, where does India stand on reusable launch vehicles?
Why you are saying all this now?
No, sir. Like,
which country is having that? No.
At what stage?
It's under development. It's under development. It's a long way to go, but it's under development.
Okay, sir. Thank you.
We are already doing all the landing gear, everything has been done.
Any other questions from audience?
Reusable means it's not economical. Huh?
Sir, I have a question to ask you. Sir, you have windmill pati சொன்னீங்க இல்லையா sir? Windmill. Windmill சொன்னீங்களா sir? We happened to read in the newspaper in the month of June last year there was a day where windmill zero energy it produced. That how come that happens?
Yeah, there are times where the atmosphere and the wind pattern will start changing, and there are a period where there will not be any wind in the coast where you are put. And that is possible. See, 100% wind will be always available everywhere nobody has put. So if you start mapping, you will find that the coastal where you put around 93% is the maximum wind speed in one particular direction. If in the reverse direction, it will be a load on the windmill. They have to stop it. They will not allow it to go. And beyond one particular speed also, windmill will not be allowed to rotate. So they will stop it. They will lock it. See, suddenly cyclone time. Since wind is there, I can't put a windmill because it cannot withstand that speed. It will break. So that they will stop it. So that is.
Thank you, sir. Thank you, sir. Sir. Thank you. Actually, you made us to understand the role of space technology in sustainable development. Thank you, sir.
Thank you so much, sir. We are immensely happy and deeply honored to have you here. We request our Rector, sir, to felicitate the speaker, Sri A. Rajarajan, sir, Director, Satish Dhawan Space Center, Indian Space Research Organization. Applauses. We request our Rector, sir, to felicitate Chair and Co-Chair of the session. Thank you, ma'am. Thank you, sir. We thank our proud sponsor, Aram IAS Academy, Chennai. Thank you. Let's break for now and be after 10 minutes.
Did you know that typical space rocket launch produces more than 1 million pounds of thrust that allows to take more than 1000 kgs of payload at the speed topping 22,000 miles per hour to space? The energy produced in space launch is so immense that it is safe to call it a controlled explosion. Today, we are going to see some of India's best and reliable rockets made by ISRO. Indian Space Research Organization or ISRO built India's first satellite, and it was launched by Soviet Union in 19th April 1975. The satellite was named after mathematician Aryabhat. India realized that depending on foreign power was not so feasible due to diplomatic reason, so is ISRO decided to make their own vehicle launch program. ISRO made its first launch vehicle called SLV or Satellite Launch Vehicle. SLV was very basic launch vehicle which was able to carry 40 kgs of payload to space. It was entirely solid fuel launch vehicle. Rocket was used to carry Rohini satellite series to low Earth orbit. The launch vehicle which replaced SLV was ASLV, which stands for Augmented Satellite Launch Vehicle in 1983. ASLV was much powerful than SLV. ASLV was able to carry payload up to 150 kg to low Earth orbit up to 400 kilometers. ASLV is used to launch the stressed Rohini satellite series to orbit around Earth over a span of 7 years of 1977 to 1984. The construction and propulsion system of ASLV are similar to SLV. Just like name suggests, ASLV used augmented solid booster to increase its range and capacity. Of the 4 total launches of ASLV, only one was successful in launching the payload to the given orbit. Due to low success rate and low payload capacity, the SLV and ASLV was discommissioned and not used anymore, then replaced by much bigger PSLV, which stands for Polar Satellite Launch Vehicle. The Polar Satellite Launch Vehicle and PSLV was developed by ISRO due to necessity of more reliable rockets. PSLV was developed to launch India's remote sensing satellite or IRS. The PSLV has its first flight in 1993, but the mission was total failure as it was not able to reach full orbit due to failure. In second stage of rocket, the following year, second PSLV was launched, which carried IRS or Indian Remote Sensing Satellite. Although rocket had rough start, PSLV has very good safety rating. The PSLV is in service in over a 2 decade. Of the 50 launches of PSLV, only 2 were complete failure up to date. Due to unmatched reliability and safety, the PSLV earned its title the workhorse of ISRO. This is because of extremely simple yet reliable and flexible design of rocket. Unlike foreign rockets, the PSLV does not totally depend on cryogenic fuel in its main stage. It is a 4-stage launch vehicle with the first and third stage using solid rocket motor, and second with 4 liquid strap-on fourth stage using liquid rocket engine. The rocket also uses strap-on solid booster to augment thrust provider first stage and depending on the number of these strap-on boosters. The PSLV is classified into its various versions like PSLV-CA, PSLV-G and PSLV-XL. Because of this modification, PSLV proved as highly versatile rocket capable of launching wide variety of payload. The PSLV was also responsible of carrying many notable payload of ISRO like India's first lunar probe Chandrayaan, Chandrayaan-1, India's first interplanetary mission Mangalyaan, and also India's first observatory Astrosat. After PSLV's success, ISRO also built GSLV, which stands for Geosynchronous Satellite Launch Vehicle. GSLV is the largest launch vehicle developed by India, which is currently in operation. This 4th generation launch vehicle is 3-stage vehicle with 4 liquid strap-ons. The indigenous cryogenic upper stage, which is site-proven, formed 3rd stage of GSLV Mark II. GSLV Mark I was launched on April 2001, successful carrier 1.5 ton of GSAT satellite to geostationary orbit. In total 6 launches of GSLV Mark I, variant 3 were successful. The Mark II variant of rocket was first launched on 15th April 2010. However, launch was a failure. This was because of a new cryogenic upper stage engine was not able to generate sufficient thrust to reach the intended orbit. Of the launch of GSLV Mark II, variant 6 was successful and only one was in, and it has proven to be very reliable launch vehicle. From January 2014, the vehicle has achieved various success. The updated version of GSLV Mark II is GSLV Mark III. GSLV Mark III was chosen to launch Chandrayaan-2 spacecraft. It is a 3-stage heavy lift launch vehicle developed by ISRO. GSLV successfully injected Chandrayaan-2, India's 2nd lunar mission, into the Earth parking orbit on 22nd July 2019. From Satish Dhawan Space Center, Sriharikota, and ISRO also has one launch vehicle which is under experimental stage called Reusable Launch Vehicle. The RLV successfully completed its first atmospheric test flight on 23 May 2016, which lasted for 770 seconds and reached a maximum altitude of 65 kilometers. It was designed to evaluate various technologies, and development of the final version is expected to take few years. The fully developed RLV is expected to take off vertically like a rocket, deploy a satellite in orbit, return to Earth, and land on a runway. This technology will be developed by ISRO in near future. Comment down which is your favorite vehicle and why. And thank you so much for watching this video. Comment topics on which you would like to see next video. Also, don't forget to subscribe. We will meet you in next video. Thank you and Jai Hind.
Hello, it's Scott Manley here. Today I want to talk about India's space program. They have a national agency called ISRO or ISRO. It's the Indian Space Research Organization. In recent years, that space agency has shown to be very competitive with other national programs, even at much lower budgets. Like, for comparison, NASA's monthly spending is probably in line with ISRO's annual spending. They get less money than Chinese or Russian space agency, and yet they're pretty effective as an agency. Like, they were also working in the commercial market. Their PSLV launch vehicle was doing pretty well, offering good prices. They've lost out a bit to SpaceX, but all the same, as a scientific agency, they were able to send a spacecraft to orbit Mars before China was able to get there. They have the best camera in lunar orbit right now, and they're planning to launch humans in coming years, possibly as early as next year. Now, in terms of rocket design, they've got a lot of domestic hardware, and most of their rockets, all of their rockets, in fact, use large solid rocket motors. They've developed this technology on their own, and there's only like the US and Europe that are building solid rocket motors of similar size. Their main rocket engine they use in terms of liquid fuel is the Vikas engine, which is an Indian-built version of the European Viking engine. That Viking engine debuted back on Ariane 1. So the Viking, or Vikas, uses UDMH and dinitrogen tetroxide with a third tank of water, which is needed to cool the gas generator exhaust so they can run the pumps without melting them. Now, they've taken the Vikas engine and started out as a clone of the Viking, but they've managed to upgrade it, and the newer versions have a lot of different performance improvements. They also have versions which are adapted for sea level use versus high altitude, vacuum use. But they also have developed a completely domestic hydrogen-oxygen upper stage engine. Originally, back in the early 90s, they were just going to buy the technology for hydrogen-oxygen engines from Russia, but there were political problems, and ultimately they were only able to buy the engines. So they then set out in 1994 to develop their own engines. And yeah, now they've got the CE 7.5 and the CE 20, and both of these are quite capable hydrogen-oxygen engines. Now, this is all what the state of where we are now, but if we go back, India's program really started probably about 50 years ago. In the mid-1970s, they launched their very first satellite. It was called Aryabhata. It was basically like an X-ray astronomy experiment. It did experiments in solar physics. This is what it was designed for, but they didn't have their own launch vehicle. They did, however, have an agreement with the Soviet Union, where Soviet Union would use Indian ports, and India, one of the benefits was that they got to launch rockets on, or satellites on, Soviet rockets. So in 1975, Aryabhata, I don't know why I can't say that. I'm sorry. It launched on a Cosmos 3M rocket, a glorious success that lasted all of like 5 days before all power on the spacecraft was lost. But it was a small step, and obviously they've become more successful since then. Very quickly, however, India set out to develop its own launch vehicles. It didn't want to be relying on the other countries. So their first vehicle that they developed was the SLV, the satellite launch vehicle. Yes, I'm going to point out that almost all Indian launch vehicles basically end up in LV. They're very, very simple, similar naming. But yeah, the SLV was an all-solid four-stage vehicle that it actually looks very similar to the US Scout, but I'm not sure there's any actual technology between the two. So it was 17 tons, 22 meters high, and it could launch about 40 kilograms into low Earth orbit. The very first launch attempt from this was in August of 1979, and it was going well up until the second stage, and then it went out of control, and this spacecraft ended up in the Bay of Bengal. A year later, they went and fixed the problems. They managed to launch a satellite, I believe called Rohini, into low Earth orbit, and that was their first successful domestically launched satellite. And it's worth noting, by the way, that Abdul Kalam, who was one of the lead scientists behind this program, he would ultimately go on to be president of India, which is a largely ceremonial position, but all the same, he was apparently very popular in this role. SLV, it was a very simple vehicle. Obviously, it used solid rocket motors all the way. It had a pre-programmed open-loop guidance trajectory, so it didn't have any way to respond to underperformance or overperformance of the thing. So the final orbit was rough, to say the least, but yeah, it was a big step for them. Now, 40 kilograms wasn't a lot, so their next step forward was the ASLV, the Augmented Satellite Launch Vehicle. And this basically took the same rocket, and they took the first stage and strapped two of them on either side of the core. So the vehicle would lift up on these two boosters first, and then those would be shed and the core would light, and that would in theory carry it into orbit. However, it didn't turn out to be very successful. They had first two launches were failures. They only really had a proper success by the end of the program in 1994.
We request the students
Part
to
of the
assemble
problem was
fast.
it was a very long and thin rocket, and that meant that they had stability issues. And when they were performing the stage separation early on, this was very low in the atmosphere. They were still inside the troposphere. So they had a lot of aerodynamic forces on it, and they're doing this lateral staging. And that turned out to be a bad design for them ultimately. The program ended because they had started developing a much bigger launch.
Moving ahead of the session, we have Dr. N. Kanya, Dean Student Affairs and Head of the Department of IT Department, to be the chair of this session. She obtained her PhD from Computer Science and Engineering. She's expertise in cloud computing, image processing, and Internet of Things. We are very happy to have you, ma'am. And we have Dr. U. Jayalakshmi, HOD of Electronics and Communication Engineering, whose expertise over telecommunications, focusing on applied electronics. We are happy to have you as co-chair, ma'am.
Good morning, everyone. We are happy to have Mrs. Kalpana Arvind, outstanding scientist, ISRO. She's a director at Leo ISRO, Bangalore. Ma'am is going to present in the title, Advancement in Electro-Optical Sensor in the Space. Electro-optical sensors are crucial components in satellite orientation, determination with reference objects such as sun, earth, stars, and magnetic fields. ISRO initial mission started with simple sun sensors and magnetometers, progressing to sophisticated star trackers and earth sensors for LEO and GEO mission. LEOs has been the forerunner in sensor and performance with FPGA and hybrid circuit technologies. These sensors are critical to attitude control, navigation, and autonomous maneuvers such as docking missions like Chandrayaan-3 and Aditya L1 have been demonstrated LEO's cutting-edge vision and laser-based systems. With in-house collaboration and optical assembly facility, LEO continues to drive India's space aspiration. Now I request my co-chair to introduce the guest.
Thank you, ma'am. It's a great honor and privilege to welcome today's guest, Mrs. Kalpana Arvind, a distinguished scientist and an inspiring trailblazer in the field of space technology. Ms. Kalpana Arvind completed her BE in Electronics and Communication Engineering with distinction from PST College of Technology, Coimbatore, under Madras University. She began her remarkable journey with ISRO in 1986 at the ISRO Satellite Center, now UR Rao Satellite Center, where she contributed significantly to the development of sensor processing electronics for the INSAT-2 series. Over a phenomenal 38-year career, she has been a key contributor to over 40 flown sensor packages for landmark missions, including INSAT, IRS, Chandrayaan 1, 2, and 3, and the Mars Orbiter mission. At the Laboratory for Electro-Optic Systems ISRO, she spearheaded the development of cutting-edge sensors such as fiber optic gyroscopes, MEMS-based sensors, star trackers, and payloads for missions like Aditya L1 and GSAT 19. Her leadership roles including serving as project manager, deputy project director, group director, and finally associate director at LEOs before her retirement in May 2024. She has published over 55 technical papers, holds 2 patents, and is an active member of numerous professional societies. Mrs. Kalpana Arvind's exceptional contributions have been widely recognized through several prestigious awards, including the Women Scientist of the Year Award by Astronautical Society of India, ISRO Team Award, India STEM Award, Distinguished Alumnus Award from PSD Tech, and the Raindrops Women Achievers Award for Science and Technology. We are truly privileged to have with us today. Please join me in giving a warm welcome to our guest, Mrs. Kalpana Arvind.
Ma'am, we welcome you. This is the first time we have women scientists from ISRO. We welcome you all.
Thank you for the introduction. Very good morning. Vanakkam, Manavargale, Manavigale, Tamil Nadu future architects of whole Bharat, I can tell. So, Nanu Tamil Nadu padichi valanda ponnu. So, whatever I can talk, whatever I have my experience, I want to share with you all. So, after the session, I want to keep more questions to come from students because morning rendu session it was like a general topic. Ipo koncham technical I am going to talk about what work we have done, what work we are going to do in future. So, let me take through this journey. So, my talk will be like this. So, I will be giving an introduction about attitude sensors and what are the new design and development of the sensors and what future we are going to make also. So this laboratory for electro-optic system is one of the leading LEOs sensors. It is meant for both attitude sensors as well as optics. In whole of India, we are the only people who can make world-class optics. And we not only make different types of sensors, we made payloads also, and we made the detectors indigenously in India. So make in India concept and making the sensors for productionizing it also is done by LEOs. We are the first people to do it in ISRO. And we have made the advanced optics where we can see a 28 centimeter object from a height of 500 kilometers using 1.1 meter optics, which was made in LEOs. So like that, I can list many things. All these things are summarized in one slide. And I just wanted to tell how we work in ISRO. Both men and women are equal. Subramania Bharati Anik Chonnar. But that is true in ISRO, where equal importance is given to both of us, and it's a place to work. And I wanted to tell our women community, ISRO is a place where both are equal and it is equal opportunities are given. If you have the passion and work, it is your talents are recognized in ISRO. That's what I wanted to tell with this. And anyway, space environment, how harsh it is. With this type of environment, we need to design, whether it is a sensors or any systems, including the payload, everything has to work under this type of environment. And what do you mean by attitude? Suppose if you put a glass, how it is? I can tell it is looking down, but with reference to what? Now I can tell it is sitting on a table. Now, is this sufficient? Now I can tell it is sitting on a room looking down. So this is what we can do with the sensors when I put a satellite in space, how it is represented. So the orientation of the satellite is represented by the sensors. They are called attitude sensors. Attitude means nothing but the orientation of the spacecraft in space. So we need to tell like a cuboid XYZ axis, we measure all the orientation with respect to yaw, roll, pitch axis, where yaw is the axis which is pointing towards Earth, roll is the axis where it moves, pitch axis is perpendicular to these two. So we make sensors to measure all these 3 axis orientations. So how the motion, both translation and rotational motion, both can be measured, and that we can give with a, when we are moving from one place to another, we need to know the position and velocity. And when you are rotating, at what rate you are rotating, the rotation rate is also important, and the direction in which you are rotating is also very important. So all these things are determined by the both orbit and attitude. So why we need this? Without this, whether satellite will not work? No. Mainly, these are all the main things, because once the launch time batteries are used, once it is put in space, solar panel has to deploy, and panel is the main source. So to point the panel to the sun to get maximum energy, we need the solar panel sensors. The other one is, once the satellite is there, we need to communicate with the satellite, so antenna has to point towards Earth. So that is one more operations. And imaging wise, the purpose for which it is sent a remote sensing satellite, so the cameras of the remote sensing satellite to look towards the Earth. So imaging operations. And if you want to move from one point to the other point, maneuvering, as well as thermal, because we have seen how much temperature is there. When sun is there, it will go to 120. When it is space, minus 150. So the thermal control also we need to do. So one more main importance is, like sensors, we put always outside the space. A star sensor which works, it's always to be pointed towards star only. It cannot see the sun. It will not work. So sensitive elements like sensors should not see the harsh source. So for all these operations, we need the attitude control. Normally, attitude control is done by all these direction cosines and Euler angles, so which I don't want to explain. So today, how the errors, if the yaw error is there, pitch error is there, roll error is there, how it is going to affect your imaging. So we need to keep the spacecraft in 3-axis controlled mode. To do that, we need the sensors. So for that, just initial, how is the different types of orbit? So which we have already, people will be knowing: low Earth orbit, geosynchronous orbit, and intermediate orbit. So in the polar orbit only, all our remote sensing satellites are working, and in the geosynchronous orbit, all our communication satellite works. And I think students, if you want to listen, you can sit quietly, or if you want me to stop talking for some time, I'll stop. Because we have come to give you a lecture for you today. It is, for both of us, it will be nice. Correct, no? Silence is better. Afterwards, you note down your questions. You can have an interactive session, so that I can, because already time is running out, so I wanted to finish also. Thank you. So already application areas, our morning, Rajarajan sir has explained. And what is the attitude requirements? If you see, for a low Earth orbit, when it is a camera which is imaging, we need to go, the order is 0.05 degrees is the attitude requirement in all 3 axes. But whereas a communication satellite where antenna only has to point, the stringent requirement is not there. So that is plus minus 0.1 to 0.2 degrees. So this is the type of things when a system satellite is requiring, I need to make a sensor 1 order or 2 order better than this. That is the requirement what comes from the spacecraft. So if you take a spacecraft, it is divided into 2 sections. One is called the mainframe systems, the other one is the payload systems. In the mainframe systems, again mechanical and electrical systems are there. In the mechanical systems, where structure, thermal, propulsion and mechanisms, things will come into picture. Whereas in the electrical section, attitude and orbit control system, where morning Dr. Vinod was talking, he walked with me. And power systems, where our director, yesterday he came and talked, he was a power expert, and telemetry and telecommand systems. So my system comes under attitude and orbit control system, which is the sensors and actuators. So where I work. Sensors, we call it as eyes of the satellite. For you, when you are walking, how your eyes are helping you to walk. Similar way, our sensors are helping for the satellites. So if we see the systems, all our sensors are the inputs to the attitude and orbit control, which is the main, like a heart or the brain for a satellite. And you were talking like ears are the telemetry telecommand systems, and which is being controlled by the thrusters and actuators. But the satellite, what it is going for the purpose, the payload, they are also is connected with the attitude and orbit control system. So this is the main system where all the subsystems are connected with the in the spacecraft. So control system is the main element where all our inputs are taken. So coming to sensors, we make sensors when you are looking in space, what is available, the source itself is used and made different types of sensors. So based on the type of source, we call them as sun sensor, star sensor, earth sensor, magnetometers. So, and some gyroscopes which are already both mechanical and fiber optics based, what I have also done, I will just touch about it. And all these sensors, they need optics and a focusing element, because the energy what is coming, either it will be too much or too less. So we need optics in all our sensors. And processing electronics, depending on that, both embedded and non-embedded systems we have done. So this is the different versions what you may be seeing. So the first one, infrared radiation from the earth is taken, and that is used for the earth sensor, and magnetic field is used for the magnetometers, and sun anyway is always available, that sun sensors. All these versions I will be covering, and star sensor are the highest accuracy sensors. See, finally what I have to measure is the orientation of the satellite with respect to some time frame. So that frame will be either it is an inertial pointing or with respect to earth pointing. So with the references with respect to inertial method. So that is what we normally tell. So based on that only attitude and orbit control, electronics will control. So that closed loop is like this, where you want the desired orientation. So the attitude control electronics will control with the actuators. So satellite dynamics will change due to solar radiation pressure and other things. So satellite orientation will change. The change in orientation is measured by the sensors, as well as the what rate it is going to be measured by the gyros. So using the sensors, that error has to be corrected. To correct that, again I will use an actuator. Actuator can be a passive or an active element. So based on that, the spacecraft will be always maintained in 3-axis orientation. And what way it is rotating, or clockwise or counterclockwise, all those telemetry monitoring inputs are available to ground to know what has happened. So this, when I am designing a sensor, what are the inputs it requires? Many inputs are required. So if you see at the input, so we have both analog and digital type. For a 5 kg satellite, of your student satellite, I cannot put a very big sensors. So simple analog sensor, a solar cell itself will do. So that is where I started with both analog and digital type. What accuracy it is, because different versions I have told. Another one is how field of view test cover, because sensors means again I have to design with an optics. I cannot put full 180-degree coverage, because sun will come at any given time. So star sensors will have normally plus or minus 40 degree only will be its field of view. Then dynamic, whether you wanted to cover plus minus 180 degree or plus minus 70 or plus minus 10 or plus minus 50 degree of the angle, what you want to come. So based on that, different varieties of sensors and where it has to be mounted, mounting details, and what is the input power, and how is the synchronization with the control system, because everything has to be synchronized with the control system. So, and what update rates, because I have to give an input for a spacecraft, what rate I am going to give my angle. Satellite can do the control. So, and over and above some on orbit, I need to send some commands to correct some errors. So data commands are required. And thermal control is a main thing for us, because it's always mounted outside. How the because all our electronics, including detectors, it doesn't work at minus 120 to plus 150. It works between 0 to 40. How to control the thermal? The thermal design of the sensor is very, very important. And last one is, because of the spacecraft separation and launch, the shock levels also, where it is getting mounted, it has to be qualified for that. And not the least, these sensors have to work throughout the mission life of the spacecraft. So how much quantities you are going to put also is an important thing. Not only this, where output wise, if I see, it goes normally to control system, but I have to monitor directly by telemetry. So some of the things will come through the telemetry. If it is a landing mission, it will come from the navigation, guidance, control, electronics, and interface-wise analog, digital, because these things are really required to reduce the size and weight, because for a nano satellite, normally serial interface. So in our case, we use MIL standard because number of data volumes are very high. So we go for MIL interface, MIL 883B. And MIL 1553 is the one what we are using, sorry. And for all these sensors, we need to give, whether my input is correct or not, for that, we give a sun present signal or an earth present signal to validate my data. Then only control system will take my input, because wrong inputs, if I give, spacecraft will start rotating, it will be catastrophic. So we give a sun presence indication and all this monitoring, and especially polarity is very, very important when we talk about sensors, because based on the polarity only spacecraft will be rotated. And all outputs can be analog, digital, and now up to 32-bit also we are giving all the inputs. So that means that is the accuracy level, and the noise in the system also is very less. So if you see the development cycle, it is a big process for us. We start with the mission requirement, then the system design. From there it comes the optics design, field of view studies, then what is the electronic design interface, mechanical design of the sensors, then what is the optics, optics will go separately, then electronics layouts, and the component, whether it is indigenous or it is imported or commercial, then based on that it will go some up screening, the design wise analog or digital, then advanced algorithms, software development, then all these things are connected together in the realization assembly. Then comes our detector focusing, because for us every sensor has to go for alignment, because finally my sensor reference will be aligned with the spacecraft reference to get that type of accuracy. Then we need to do calibration, how the sensors are going to behave in onboard. Similar way, I need to do the calibration, get all the scale factors and the noise and the accuracies. I have to prove it on ground. Then environmental test, because spacecraft, whatever environmental means, both thermo-vacuum and vibration has to be done, including shock test. Then onboard calibration also we do. The qualified sensor will be going for both production as well as for mission requirements. If any onboard observation, again the cycle continues. So coming to magnetometers, yeah. No, we make our own FPGA for the particular design, because FPGAs are field programmable. So same design, sometimes it goes for a production, but sometimes if we see onboard modification, we do changes in the software also. Next version, version 1, version 2 will be there in the FPGA coding also. No, so FPGA is bought out system. You have to one time program it and wire it. So field programmable gate array, but we have ASIC also, where we have used continuously for earth sensors, we have used ASICs. So for, okay, it will be quite interesting. It's not a problem, because now it's like that. No, the process will be, some will be less. I don't need to go through the that much. So some of the things will not be there. So it depends upon the nano satellite or that we, some of the things will, but for a star sensor means that much thing will be there, whether it is a nano star sensor or a big star sensor. It is required. So it depends on the technology or the sensors. So you can just see here, 1975, as they told Aryabhatta itself, my guru was the first designer for the magnetometer. So it started with 500 gamma. Our Earth's magnetic field is plus minus 50,000. Gamma is the dynamic range. So 500 gamma was the design. Today we have gone to almost 30 gamma, and for Aditya L1 we have got almost 1 gamma resolution we have made, and it is working very beautifully in Aditya L1. So this is the technology, and this is what I wanted to tell you, how we are able to get it. And the payload wise, it is measuring the magnetic coronal mass ejection time, magnetic field changes. That change is only to 30 to 50 gamma. That much change we have to sense. That's why the highest accuracy. So the payload is working very beautifully. And coming to analog sense sensors, they are the very simple sensors which give accuracy of 5 degree to arc second we have made, but analog sensors maximum accuracy is plus minus 1 degree, 5 degree to plus minus 1 degree. So these are all the different versions. And for Aditya L1, I can proudly say that we have made arc second accuracy using a sun sensor, because it's very difficult, but using a pinhole technology and a CCD, we were able to get arc second accuracy, and L1 requires less than 5 arc second accuracy. Our sensor can give 10 arc second. One more issue was the size and weight of the satellite also dictates the size of the sensors. I can make 1 arc second accuracy star sensor, but the weight will be more. But within the same weight, I have to make, means we were not able to meet with the star sensor, so we made almost this sensor weight is only 1 kg, less than a kg. So this is the design. So if you see the high accuracy, 150 grams is the weight. And it is also working very nicely. And simple principle wise, any sun sensor output, solar cell output is a cosine curve. The cosine curve, it is very difficult to differentiate the accuracy. So we do linearization by using summing as well as dividing option. We get signal. So this is just a simple thing. Sunlight enters through a slit. So we get both solar cell outputs, whatever is coming, current to voltage conversion. And if you sum it, you get the sun presence. If you divide, the cause effect goes and we get the angle output directly. So coming to digital, we use pinhole technology, either an N-type slit or a through pinhole. And the processing electronics, we use CCD as the detectors. So the accuracy goes higher here, 0.05 degree. And coming to earth sensor also, this is from IRS 1A onwards, and INSAT 2 also, we have made all different varieties of sensors. Originally we made all discrete versions. Later on, we have to reduce the size, weight, power. So we came to ASIC as well as field programmable gate arrays. And the interfaces also are reduced, and thanks to the silicon technology. So now these are all the different versions. The purpose is when you Earth will look like a disk. So the scanning system is required is to move left to right. So that is the only scanning mechanism. But if we go to geo, the Earth will be looking very big. So we used to do a full 360-degree scanning mechanism. So that is how we have designed. And this scanning mechanism has worked more than 10 years and is flying in low Earth orbit. Whereas star sensor is the main sensor, these sensors are used as backup sensors. And roadmap of stars also, if you see from Mark 1, we call it as different version, Mark 1 to Mark 4, and made one nano star sensor also, which is patented. It is only 70 grams. The accuracy is almost equivalent to Mark 3. Mark 3, what it is giving 10 arc seconds in both roll and pitch, and yaw side 40 arc seconds. Similar performance which is flown in INS-2 TD. It is a fully indigenous technology, but components are all commercial components. How we do is, we take the image of the star, and the star image is compared with the what is stored image in the star. We have a star catalog. Using that, we can tell, because stars are quite steady and it doesn't move with time. So with respect to that, we can get the accuracies very, very high. So that is how we are able to get to the highest accuracy using CCDs. Nowadays, the CCD technology also is very good. So we were able to get accuracies of the order of 1 arc second. So we use both active pixel sensor as well as charge coupled devices, the detectors. So they are all working autonomously. So once you switch it on, it will see the sky, and it will check the scan first, acquisition mode. Once it is acquired, then it will come into track mode. From track mode onwards, it will continuously give update to the control systems. And this is the sensor which can give all 3 axes, whereas earth sensor and sun sensor will give only 2 axis information. So this is the table what I wanted to show, what are all the things it can work, and we are able to give at 8 Hertz update rate. And the field of view, why I was telling you how it is very important. So we do studies about the field of view of the sensor so that it will not get affected by the solar panel or the reflector while mounting. So all these things also we take care. And to characterize these sensors, we have already, for a sun sensor, sun simulator, which simulates the same sun spectrum. And for Earth, we have same infrared radiation we are simulating. And star sensors also, both dynamic star movement as well as stationary star movement, both we have at the facilities. And magnetometers without any iron, we have made a special setup where we can do, it is away from everything, and it is having a Helmholtz coil, so where we do calibration for the magnetometers. And coming to fiber optic gyro, normally mechanical gyro is used both in aircraft and spacecraft and rockets also. This technology is a solid state technology where I have worked, and this gives, it works like this effect called Sagnac effect. When you pass two light waves in a coil, fiber coil, both clockwise and counterclockwise will come at the same phase when there is no rotation. When there is a rotation, the change in phase will be there. So change in space, we are measuring the rotation rate. So these sensors all are made indigenous in components alone procured commercially, and it is qualified for space use, and it is working from 2015 to till more than 10 years. The sensors are working very nicely. This is the first sensor what we made, single axis sensor, to demonstrate the technology. We were able to give 0.0002 is the random walk, that's the noise, and if you keep the sensor on 0.02 degree per hour, it will not drift. So this is the sensor which is being used in Cartosat 3, where the platform should be very stable to get that less than 30 centimeter accuracy objects. Every missions, both attitude sensors as well as accelerometers are required to know the things. So every sensors are used. And we made indigenous detectors in our LEOs, both the solar cell as well as bolometers, which is the main detector for the Earth sensor. We are the only, globally, we are the only people who have made the bolometers in-house. And we have made silicon carbide radar UV detectors, terahertz detectors, so, and dual axis sun sensor with the MEMS technology. So all these things are done in-house. And we have made payloads also. At present, this Gaganyaan dosimeter, which is flown in Microsat 2C, is working very well, which will be used for the Gaganyaan program to measure the inside, what is the radiation levels. So over and above, we have a MEMS lab also in our LEOs. So using MEMS technology, we have made accelerometers, which is already flown, and the same thing was flown in Chandrayaan 2 and 3 for the lander inclination measurement as well as the rover inclination measurement. And being in electro-optic systems, these are all the refractive optics is what we have made at LEOs. It is being used for both payloads as well as for our sensors. And these are the reflective optics. This is the optics what we have made at LEOs, and the 1.2 meter Cartosat 3 is the highest diameter thing what we have made at LEOs. And these are all the things, these payloads are done by SAC Ahmedabad. If we see from earlier technology wise, the resolution was 1000 meter. Today we are able to reach 0.28 meter is the resolution. So that much size of the object we can see from space. And not only that, we make different coatings also in our place. So we are making coatings for all the sensors as well as for the optics, and for the star sensor we need a baffle so that it will, sun rays will not enter the detector. And coming to Chandrayaan 2 and 3, where the navigation type sensors are required, so we made the technology with laser based technologies. That was the first time. So this is the power design phase. I think everybody knows about it, how we have made, and how the difference between a satellite which is there in orbit and the landing. Here we need to measure the velocity and the position. Both are required accurately so that we can land the precise point. So for that we made, here just I wanted to put this because Chandrayaan 2, when it failed, everybody was very upset, but the word itself said nothing is impossible. it says, I am possible. So that is what we have done. And with that, the same sensors, whatever we have designed in Chandrayaan 2, 3, and the lessons learned. Normally, people think what is there in the failure. No, failures are the things where you can learn the lessons and correct yourself. It applies to not only space technology, even in our life also. So that is how we made, and these are all the new sensors what we made, and using both vision-based technology, using a camera itself, because we came out with things how to measure the velocity, because both gyros and accelerometers are there in the spacecraft, but they need absolute correction when it is really required for an absolute precise landing. So all our sensors are absolutely, it has to give the correction. It should not depend on any technology. So we came up with the idea of lasers to measure the position. So laser, what we have done is the blue colored one, laser altimeter. That's a LASA. It measures the z-axis or the where it was mounted was in such a way that wherever the orientation, I'll just wanted to go back. So this is the point attitude hold phase, where at 7.4 kilometers, the spacecraft, it was mounted 50 degrees with respect to the lander. So at that point, it has to measure the height at 7.4 kilometers, that is attitude hold phase, and the and continuously again fine braking phase and the terminal descent phase. It has to measure the height. So both velocity also we have to measure. So velocity, we came with a camera technology where it takes a picture, then one more picture. Using these two pictures, we were able to give X and Y, two-axis velocity information. So new technology and FFT techniques were used, and it was able to give the accuracy. And during the laser Doppler velocimeter, which is the main sensor which can give all three axis velocity measurement, we tried in Chandrayaan 2, but Chandrayaan 2 we couldn't launch, but Chandrayaan 3 we launched it. And attitude sensor wise, star sensor was there. And linear, from ISRO, they have given the both laser-based gyroscope. The technology there and ours is slightly different, because fiber optic technology where it sees, because continuously the engine will be firing here, I need to reduce the speed of the engine when we are landing. So this technology of fiber optics, we had some issues. So we couldn't fly it, whereas LIRAP technology, it has worked well. So that is a laser-based inertial reference unit from ISRO. So just I wanted to give the glimpse of how the sensor worked. It is simple. You have to send a laser beam to the surface. The return beam comes with a phase shift. So that time difference only we are measuring and telling the position. So this is the simple technology. And we were able to give it with an accuracy of plus minus 1 meter. And now the accuracy is improved less than 100 meter to plus minus 0.5 meter, because as we come closer to the moon surface, the accuracy should be improved. And camera is already I have explained. It takes two pictures, and the difference is calculated with respect to X and Y pixel shift. From pixel shift, we were calculating the velocity. Here we have accuracies of 1 meter per second to 0.3 meter per second, and it gave the update in Chandrayaan 3. And laser Doppler velocimeter, here three lasers are pointed at 0, 120, 240 degrees. And the phase shift, what it comes back, it's a Doppler shift, people can know. Using the Doppler shift, we were able to tell the velocity. That is the principle wise. And these are all the technologies what we have used. And to calibrate these sensors, we went at different places using the targets as well as Vizag and some hills. We have to demonstrate. Not only that, we have to demonstrate the technology with the engine in loop at Sriharikota. And all these tests gave a full knowledge about the sensors and how it worked in closed loop. So everything was demonstrated on ground. So Chandrayaan 3, we were very confident that we will, surely everything will work. So, and apart from that, using the same MEMS technology, we thought we'll make some science payload seismic activity studies at landing. When it is landed, that 15 days time, whether we can measure any earthquakes or moonquakes. Actually, it is not earthquakes, moonquakes, whether we can measure. So the technology was enhanced to measure 100 nano-G is the accuracy which we have done. And this sensor also worked very well. And coming to rover, we made the camera, which made the sensors to move. Actually, this time we didn't do it in real time. We took the camera, both the images, that from 2 images, we got the digital elevation model on ground. Based on the elevation model, where hazard is there, the rover was made to move. So this is how we have moved. And the right side image where the lander is landing, this picture was taken by the Chandrayaan 2 orbiter. And this is the selfie taken by the rover camera where this lander is landed. So these are all the things where our people have worked. And here we have put one more laser-induced breakdown spectroscopy. It's based laser. Laser is pointed to the moon surface. Whatever plasma it comes, the plasma is captured, and the minerals, what it contains, is being analyzed by this instrument. And this instrument also worked very well. And coming to Aditya, anyway, already people know where it has reached and why it was very important. And being there, it can observe the sun without any disturbance, because it takes almost 185 days to be there. It took 109 Earth days to reach the point. Once it is there in the Lagrangian point, sun is like a stable source, so we can study about the sun fully. So different sensors as well as attitude sensor, so star sensor plus that high accuracy pixel sensors we have delivered, and payload wise already, which I have already talked about it. And over and above, we have contributed for the visible emission line coronagraph and solar ultraviolet light imaging telescope optics. So that is what I wanted to tell you. This is the optics design, and these are all the optics what LEOS has delivered, and these are all the actual pictures what is taken from sun, from Aditya L1. And for VLC payload also, LEOS has delivered all the optics required, and it's a very complex optics design where each and every lens alignment and focusing was very, very important. And on-orbit performance-wise, it is working, but not up to the required performance-wise. This is the payload, what magnetometer payload, and we have compared with the Discover one satellite already sitting there, and it was matching very well with that. So this magnetometer also worked, and here we have used, it's the magnetic boom which was deployed in space. Around 6 meters is the boom length. And the other important mission is the docking mission. Compared to moon mission, here two spacecrafts are there where we have to dock. So here the same laser altimeter, we modified it. Only thing is I have to get the return signal from the other spacecraft. So we have used a retro reflector which is mounted in the other spacecraft. So that way laser altimeter was used. And over and above, we have used different, for the full docking time also we have used different sensors. So these are all the different sensors what we have designed. The laser range finder was slightly modified. We used a laser diode for this laser range finder, and for the synchronization purpose we have used a laser diode which gives a signal indication so that both the spacecraft are coming at a different time interval. So that synchronization, how to do it. So I am scanning from here. So used a laser at the other opposite end. We have used the synchronization. So that is also very important. And for the nearby range, we used a camera-based techniques where image recognition and centroid computing. So we need to give 6 degrees of freedom. It's not 3 degrees of angle alone. I have to give both X, Y, Z angle as well as position. So all were given. And anyway, so these are all the different distances where the sensors will be working. So that is what I have shown here. And this already how the laser diode image, when it is far, it will look like a single image. When it comes nearby, it will look separated. So using that separation only, we can give higher accuracy. So these are all the things how we did the alignment. So at far, all 8 image will look like a single image. As we come closer, the images will separate. So using the laser image, the cameras were capturing the things, and we got the position 6 degrees of freedom. And these things were calibrated using our rendezvous simulation lab. So these are all the things. Now coming to future activities wise, anyway, Gaganyaan mission is the upcoming mission. So where the human safety is very much required. So the attitude sensor, it has to bring back the people carefully. So attitude sensors are really very much, it has to measure and give. So the redundancy wise, here we have given normally 2 redundancy or 3 redundancy will be there. But for Gaganyaan mission, we have gone with 4 sensors as a redundancy. And coming to other things like already the existing satellite, we wanted to do the servicing missions. So these are all the future things what we need, how to use the other spacecraft, how to inspect or you can service it. And Bharati Antariksh Station, anyway, he has talked about it. So what are all the technologies we need to do this? So not only anyway lasers are there, already we have made a rendezvous camera and cameras also are available. Over and above, the flash lidar is the technology where you can use and sensors, satellite image you can capture, and it can be used for both landing mission as well as tracking mission. But for this particular mission, the detector availability was not, it is very critical for the mission, we couldn't get it. So we didn't do it, but in the future, we are going to do it. This same flash lidar, we can do it in a 3D mode also. So existing point cloud image, already existing satellite we are collecting. It's like AI, what you people are talking. We are going to collect. So when I'm coming and going to do the docking for the other satellite from far distance itself, we can capture and we can give the 6 degree of freedom information. And now, not only that, our ISS station, now International Space Station also, if you want to do docking, you need to use their standard. So using their standard, how to dock with our satellite also, we are working on that. And other one is AI camera, because as we come very close by, the robotic arm has to capture the other one, and to do that, accuracy is very, very important. So the cameras which are going to be there to capture which is the point. So that also we are working towards that. And just I wanted to put this photo where not only women, this many women have worked in Chandrayaan. So I wanted to show this photo. And in success doesn't come simply unless you do the hard work. So in ISRO, we do teamwork. So that same teamwork applies to education also. Share your knowledge, take your friends along with you. That's what I wanted to tell you. And finally, I wanted to tell Abdul Kalam's quote. So with this, I wanted to conclude. Before concluding, I just wanted to tell, today he was talking so much about our Earth. He was telling we will go to Chandra, Moon or Mars or somewhere. But before we go there, we should protect our planet. So what we have to do, please do on Earth. And in space also, we have already crowded. How to remove these debris, how to reuse these debris, that is also the future challenge. Please do both of them. We have only one planet. Let us save this planet. Any questions?
Thank you, ma'am. It was a wonderful session. You have covered almost from the basics to the future plan. You have clearly explained about the attitude control in space, what are the applications in the area of satellite in attitude control, and what are the LEO usage of sensors in controlling the attitude, and what are the various attitude sensors. Then what are the sensor development life cycle? The diagram is very, that is what to say, it's a fantabulous way to explain the process involved in life cycle of sensor development. And you have covered everything till the future plan. And the quotes you have mentioned in between is very impressive. Thanks a lot for knowledgeable session, ma'am. Thank you.
Thank you.
Questions?
I want a question from students. Yeah, ma'am. Ma'am is very much interested.
மேம் வணக்கம் மேம், என் பேர் யூ.
ஓகே ஓகே.
இப்போ சென்சார் வந்து இப்போ நீங்கள் சொன்னீங்களே, இப்போ இந்தியாவில் வந்து அதிகமான எந்தெந்த சென்சார் மேம்?
ஒரு நிமிஷம் மேடம், ஐ வாஸ் டாக்கிங் 1 minute. No, already the concept, how we are going to do, how each time the satellite will go, and then next satellite, how it is going to get connected, and if 2-3 stations are there, how each one will get interconnected. All those concepts are finalized, and how to make use of commercial components. See, main issue in space is the components is the cost is very high. Now once humans are going to be there, they can do the repair work. So we are going to make it like a modular design where one particular portion, when it goes bad, any person, you remove this mod, put this new one, and I can bring it to ground and do servicing. So that type of concepts are possible in Bharatiya Antariksh Station. So the technology wise, we are going to be modular design, simple, and use the existing technology, what is available technology, and come with the innovative techniques like all our house, how we have Wi-Fi, all those things we are going to use there also, and interconnection from one panel to the other, power-wise also. See, I need not simply fly every power system everywhere panel. See, once weight is a main big issue in space. Lesser the weight, more things I can send it. So these are all the technologies, and even flexible solar panels we are talking, so that weight will be very less, still it will do the power things. And how to replace. See, anything when you do, how to replace also you should plan ahead. So that are all the technologies what these people have to come out with in future. Already ISRO has got a vision. That vision has to be realized. Already concepts are finalized. That's what I wanted to tell. Yeah, thank you. Yeah, somebody was asking. Chalpa. சேட்டலைட்டில் அதிகமாக எது யூஸ் பண்ணோன்னா சன் சென்சர்ஸ் தான் ஜாஸ்தி இருக்கும். ஏன்னா சன் ஆஸ் த ஸ்பேஸ் கிராஃப்ட் ரொட்டேட் ஆகிறப்ப இட் கோஸ் ஃபார் எஸ்பெஷலி கம்யூனிகேஷன் சேட்டலைட் எர்த் ஒரு 24 ஹவர்ஸில் ஃபுல் 360 ரொட்டேட் ஆகிறப்ப ஸ்பேஸ் கிராஃப்ட் ஆல்சோ ரொட்டேட்ஸ். ஸோ வென் ஐ எம் ரொட்டேட்டிங் 24/7 ஆல் 4 sides I have to put sun sensors. ஸோ நார்மலாக கம்யூனிகேஷன் சேட்டலைட்டில் 10 சன் சென்சர் இருக்கும். 8 will be there, 2 will be additional. ஸோ 10 sun sensors இருக்கும். நார்மலாக எர்த் சென்சர் அண்ட் ஸ்டார் சென்சரில் எடுத்துக்கிட்டிங்கன்னா 2 ஆர் மேக்ஸிமம் 3, பிகாஸ் த காம்ப்ளெக்சிட்டி இன் டிசைன் வைஸ் வெரி ஹை இன் ஸ்டார் சென்சர் அண்ட் எர்த் சென்சர்ஸ். ஏன்னா அதில் ஸ்கேனிங் மெக்கானிசம் இருக்குது. வேறு சன் சென்சர் இட்ஸ் சிம்பிள், இட்ஸ் ஒன்லி 2 solar cells I have to use, and the size is also smaller. Processing electronics I can do into multiplexing பண்ணிக்கலாம். So that are all the advantages. Okay. Yeah. I think next session speaker time ஆகும் போல இருக்கு, பரவாயில்லை. And I like to interact with the students.
Good afternoon.
At least one of you, if you join in ISRO, I am really very happy. I have done my duty.
Thank you. Ma'am, you.
Yeah.
Good afternoon, ma'am. I am Kishore Kumar.
Yeah.
I already researched ISRO and space and all. Nowadays, we have more technology. Why humans are not good for the moon nowadays? Because of past NASA, they are send Apollo mission, take over the more Apollo mission, and they are good for the moon. Nowadays, we have the advanced technology. Why we can't go to the moon?
To go to moon, first rocket technology I have to improve. Correct, no?
Yes.
Still date, we have not put a human there. So that is where the Gaganyaan mission we have started. See, ISRO started the vision like it has to meet the common man's requirement. So that we have met now. So now we are going to the advanced technology. We were not having enough budget to start that. And the technology wise, now only the cryo engine technology we have advanced. Some of the technologies are not available to ISRO. Okay, it is through hard work, people have come out with the cryo technology where it can lift more weight. That is very much required. Now only we have come. So now we are planning, but human is involved, so risk is high. So we need to demonstrate the technology first before taking the human. So that is what Gaganyaan 1 and 2 are going to do. Gaganyaan 3, anyway already 4 astronauts are selected, no? You have seen. Yes, so people are already ready, technology is getting ready. We have to demonstrate and we have to progress. Okay, and once this is done, see already Artemis program, what NASA is planning is, they are going to make moon colony. Okay, for that already they have going advanced. So we also may join there, but it takes some time. But before that, we wanted to do the lunar sample return program. That is the Chandrayaan 4. Okay. So there are some of the technologies like docking, undocking, all those things. If you do only, we can land properly. So demonstrating technology in 0G condition is very, very, very important first.
What are the problems are faced from the human in the space, ma'am? Can you tell about
See, right now in our place, main thing was taking them safely and returning back. Now we have all the technologies and the risk involved, everything is known. people are progressing. So we are very confident now we can take the person and we can return back. For that, all technology demonstrations in ISRO, everything has to be demonstrated first. It's qualification first. Once qualified, 1 and 2. 2 times successively it has to be qualified. Then 3rd times we are very confident. See, once human is involved, the risks are more. People don't want to take risk. Okay, so we are slightly cautious in that way, and budget also should be available parallel, these missions.
But nowadays, youngsters are interested, ma'am, in the space research.
Correct. We can do, you come with the technology where you can lift 10 ton in one go and you can go and come back. It will be very easy. So that is what we are looking for the younger generation.
Compulsory, ma'am. We meet in ISRO. Thank
Yes.
you, ma'am.
Thank you.
Congratulations for this.
I think next speaker has to speak, and செவிக்கு உணவில் சிறிது வயிற்றுக்கும் ஈயப்படும் அன்றைக்கே சொல்லியிருக்காரு. உங்களுக்கும் சாப்பாடுக்கு பசிக்குதோ என்னமோ தெரியாது, பிகாஸ் நெக்ஸ்ட் ஸ்பீக்கர் இஸ் ஆல்சோ வெயிட்டிங். யூ கேன் ஆஸ்க் யுவர் கொஸ்டின்ஸ் டு மீ லேட்டர் ஆன். That is better. We can talk. I will be there till 2:33 also. Okay.
Thank you.
Thank you for your patience.
Thank you for your answers, ma'am. Ma'am will be available offline. Offline, you can ask the questions. Thank you.
அரங்கில் அமர்ந்திருக்கும் மாணவர்கள் மிகவும் அதிர்ஷ்டசாலிகள் என்பதை நான் நிச்சயமாக சொல்லுவேன். ஏன்னா மற்ற மாணவர்களுக்கு இந்த வாய்ப்பு கிடைக்கல. You got an excellent opportunity to hear Madam's experience. It is not available anywhere in the book. So I am suggesting, I am requesting our Madam to come to MGR University and take lecture 1 or 2 days for our electronics students from first year to final year and our teachers, so that we will establish a research activities in electronics, especially with the sensors and satellites. Thank you very much.
Thank you, sir. It's now time to honor our guest speaker, Ms. Kalpana Arvind, Outstanding Scientist, ISRO, Associate Director at LEOS, ISRO. தான் போகும் இடமெல்லாம் பவித்திரமாக்குவாளாம் பெண். In that way, you lighten the entire crowd. Thank you so much, ma'am.
Now it's time for the second session. Now we are having the speaker, Dr. Praksha Rao. Prakash Rao, Chairman, Project Monitoring System. Title about it.
Sir,
he's going to have the session on the title, Handling the Transition, Free Classroom to Clean Room.
Very fortunate to have you, as we are having double dhamaka today. Speaking concisely is an art. Sir is an impressive speaker who can connect with the audience. சொல்ல வந்ததை அழகாக சொல்லுவது ஒரு கலை அல்லவா? அறிவுரை கூறும் இடத்தில் அனுபவத்தை கூறுங்கள் அப்படின்னு சொல்லுவாங்க. So sir's talk is filled with or sprinkled with lovable and lively examples, experiences and simplicity. Thank you, sir.
My anubhava is shown here. So, people, morning Rajarajan and now Kalpana, both of them have taken you to stars or much beyond. Rajarajan told millions of people living in moon and all. I want to bring you down to earth again, okay? I will just talk about what is there ahead of you soon after you pass out, okay? Even first year students, right from now itself, you can prepare. This is the handling the transition from classroom to clean room. You may be wondering what is this? Classroom, anyway, all of you know, your HODs are here, your lecturer is here, all your teachers are here. Clean room is the place we assemble the spacecrafts. So I am just, it's as a representative basis, I am telling clean room. But it is basically in one way you can tell from college to corporate or whatever like that. So how you have to be prepared for the job. What is it that you encounter when you go from a college to the whatever institution, wherever you are going to join. This is what I am going to tell. This is going to be useful to you if you take it properly. If you continue to whisper like that, that is also fine. here you can do all that, but when you do an institution, it's not easy. You can be getting your love letter next day itself, okay? Especially if it is a private company. So I will tell, first of all, yeah, what is this transition? When we are talking transition, what is this transition? That is from, this is not from any management book I have taken. This is purely because once our PPEG requested, suddenly they needed an urgent speaker. So they requested, sir, by tomorrow you have to talk on any topic of your choice. So that is for new inductees at ISRO. So overnight I prepared this preparation. So it's just from my own thinking and my own experiences, okay? Yeah, that's nice. Okay, thank you. So it is from dependent to independent. All these days you are dependent. In whatever way you are doing, you are dependent, correct? So for your money, paying your fee, or if you want to watch a movie, if you want to bunk college and go for some, okay, one good dinner or anything like that, you have to depend on the money provided by your parents, okay? So, or many other things. If you want to go to a movie also, you have to tell someone and go. But once you go to a setting where you are going to take an employment and maybe you move away from your own town, you are becoming independent. So it's, you may think a lot of freedom is there. Along with freedom comes a lot of responsibility. Whatever all these days your seniors or your parents are taking care, that you have to now depend on yourself. So you have to decide your fate. Then receive to transmit. All these days you are receiving knowledge. Your teachers are telling, maybe some seminar like this, when the Rector sir gives an opportunity, out of so many, some 4 or 5 students are getting the opportunity to tell what they have done. But when you join an organization, you are going to deliver. See, all these days you are absorbing, except during examination only you are writing. But here you have to deliver every time. Then knowledge gap. The moment you go and join an organization, you may start feeling, because people are so much well accomplished, people are there like Kalpana, okay, you see, and you feel, oh, they know so much, I don't know anything. That kind of feeling you may get. Though it's not so, you have got your own strengths, you have got so much to contribute, that is another thing. Then theory to practice. Most of the time, at least in our educational institutions, we emphasize more on theory, correct? But once you join an organization, you have to practice. So is different. This will be more on the practical aspects, okay? So that is where you have to, it is a lot of difference between, you also have some, okay, that's there. Self versus organization. All along when you are working so far, it is to get good scores for yourself, good grading or good marks or whatever it is, correct? That when you join an organization, you are doing whatever you are doing, it is for the benefit of the organization, not for yourself. In the process, you may get benefited, but the work you are doing is for the organization. So that is a major difference which you have to note. And anarchy to hierarchy, okay? Whatever you want, you can talk, like I said. One monitor will come there in between. I have seen Cyril sir coming in between, behind. All that is fine. So we can be little bit of freedom and all is there. But in organization, when you join, this kind of freedom will not be there. So you have to learn and equip yourself to abide by the rules and regulations of the organization, okay? Then hostels to quarters, okay? All along you're in hostels, correct? Yesterday, I think Hari was mentioning how the hostels, life and all. We also, whenever we used to wait in hostels, we used to wait for power cut. Because the moment power is cut, we can all come out, hey, like that, everybody will be shouting. All the 6 blocks in Regional Engineering College, we used to come out and celebrate. Because not reading is not due to our fault. Next day exam may be there, everybody wants to study, but mood is not there. When power is gone, we come out and enjoy, okay? So that is the type of atmosphere in hostels. But now from there, if you move to quarters, this kind of thing, if the moment you make some noise, your neighbor will complain, okay? So that's a different type of thing. And records to results. Even in colleges, other experiments we are doing or reports you are supposed to prepare, you are supposed to do it in yourself, but we all know, even I have done that. One person used to prepare a record or report and everybody will copy, correct? So that is a normal way our project reports are done. Or sometimes those days, if you pay some, in our time, 40 or 100 rupees, somewhere some reports also, records also you can buy. Okay, project report you can be pair and all that. B.Tech, M.Tech is slightly different. Okay, but here you have to produce results when you join an organization. So there is a mirror. So ultimately, if you have to sum up the whole slide into one word, I think it is freedom versus responsibility. Okay, so that is the basic transition which you have to be prepared for. If you are not prepared for this, organization will make you prepare. One dhamka or one good nice shouting from your boss, it will be different. A teacher shouting is okay. Teacher is like a parent. No, whatever you do, you have very much freedom with them. Parents' love is different. Whatever they may shout, they may hit you also. But with all that, finally, parent is parent only, correct? But boss is not like that. One kick, you are out of the organization, okay? So understand that it's okay. Even if I don't teach all this, you will go and learn yourself. But one cycle time I am trying to reduce, so that the moment you go among 4 people, you may be one of the best your boss will like, okay? So generally expectations for a new entrant, especially in an R&D organization if you join, what you are expecting to do. So you want to work in design and analysis area. Our time, if you go interview, if they ask what is your favorite subject, everybody tells what is that microprocessor, okay? Today if you ask anybody, everybody will tell AML. Everybody favorite subject, because we are not thinking ourselves, we are always influenced by the environment around us. Like yesterday we talked about environment, so that is there. But to do something new, everybody wants to do something different like that. And recognition, everybody wants. Who doesn't want appreciation? Even after giving so many talks, when sir like Rector like sir gives one memento, we feel very happy, you know. So we want that appreciation, all that is there. And career growth, of course, that's what we are there for that. But you have to understand the expectations of your office or your boss, okay? So that's where the professionalism they want. Initiative, it has to come from you. Don't expect that you will be asked to do whatever you have to do. Work assignment may be given, but how to do it and all that assignment, initiative has to come from yourself. That's what they expect. And responsibility, resourcefulness, capability to find non-routine solutions, loyalty. This is very, very important. It may look, you can tell he is chamcha and all that, or whatever you want you can tell, okay, or he is soaping the boss, all that. But the loyalty to the organization, not to the individual, but loyalty to the company where you are employed is very, very important. And ability to work as a team member. We are all very good as individuals, but to work in a team, okay, so that is another very important aspect. And bosses can forgive mistakes, but if you are lying, you are gone, because once the trust deficit comes, you tell for silly reasons, you try to tell lies, when really some important thing is there, even if you tell truth, nobody will believe you. So it's important that you try to be honest and be truthful, okay? So where you can make difference then? New ideas, new concept, ease with latest tools. So this is where your existing people, because now I don't know any of the mathematical modeling and all, new tools and all, because people there are experienced, they cannot learn new concepts. It becomes difficult as the seniors get aged and all that. But that is where you youngsters can make a difference. And knowledge of latest concepts, optimization, fearlessness, eagerness to experiment. You are not afraid about failing. So that is a very good quality. And unbridled enthusiasm, quick bonding with people, networking skills. These are all important. And one of the major things, especially in space department, is you may feel that you have got a great, wonderful idea. Okay, Hari is still behind me. He thinks that he has got some very good idea which can be used in Gaganyaan. Okay, so but when you are, but this idea may or may not be finding immediate acceptance in the organization. The reasons can be many. One is the idea that you are thinking is great and need not be really great. Okay, that is the first thing. So somebody for this one slide made cat will be looking itself in a mirror, and other side you will be seeing some tiger. Okay, so you may think you are having like a tiger-like idea, but it may be like a cat only. So that we have to be. So if somebody says no to you, don't get annoyed. So it is part of the things. Then heritage. This is an aspect. Because a system, if it is working, nobody would like to disturb unless there is a compelling reason to do so. That is another aspect. Okay, then long gestation time to implement new idea. especially in government, anything needs so much of procedure in procurement, approvals, review cycles, all that is there. Number of reviews you have to face, differences amongst your seniors, this is another thing. Sometimes we, even in car, we will be talking all gossip, okay? Your seniors will be talking about the other senior, maybe, but you should not interfere there and tell your own view. It is good not to give your gyan. You just act as though you have not even listened to that, okay? Listen to that. So because that is anyway, actually seniors should have responsibility, but they won't, because we are what we are. So, but you should not intervene in that. And if you intervene and talk something, it may damage you someday. So never get inspired by that, okay? And gossip among senior, and whenever gossip is there, it will never be for positive, correct? Whenever we gossip, it is always about some problem of the other fellow only. So in those things, being a new entrant, you don't do it. After putting 10, 20 years experience, okay, you will decide yourself to do or not, because you know the impact, okay? So this is another thing you have to see. Then Isaac, many people will ask that what makes ISRO so successful? Let me tell you, it's not just ISRO. There are so many government departments which are doing wonderfully. Like our railways, you take Bombay, you go and see local train. It's a wonder how many people will come, go, how they cross. To 1 second accuracy, the train will come, go in our own chaotic setup. So there are many departments doing, but like yesterday Shankaran told, space is glamorous, so you will get to see a lot of coverage. Whatever we do will be applauded. But there are many government, non-government departments and all also where wonderful work is happening. So, but still being from ISRO, people ask the question. So I'm just prepared, what is it that makes ISRO successful? We can do it spirit. Then celebrate each other's success, which youngsters will be generally having. Okay, except some Chatur-like fellow in 3 Idiots, that's a different aspect. But okay, finally he also comes down, correct? Rise to the occasion, not deterred by setbacks, openness. So like this, so many, you can go through slides. So there are so many, I told you, even wherever you go, there will be so many associations, events are there. In ISAC, if you take, for example, now URSC, Technology Day we celebrate, Science Day, some welfare association, Hindi Divas, Rajyosava, Kannada Rajyosava, Grand Slam cricket we are having, sports events, even retirement functions are so special. Photography, trekking, Kalpana is a member of our trekking club. Oh, we have got a Upagrah, VU2U, RC, like that. So many events, all this we do in our URSC, Satellite Center. But also, we also make satellites, okay? So that's the thing. So field of work, everybody, as I told, want to do work in design and analysis, but organization needs people from all the areas, which I have mentioned here: design, analysis, fabrication, test and evaluation, product, facilities. I joined QA. I was put in QA, not I joined. The moment I come out of admin office, my friend was there, senior. He asked me, where are you? QA. Oh, Papa, QA, na. Okay. So you are in QA, poor fellow, like that. So don't get worried about that. Some of our directors are from QA background. So it doesn't matter which area you started. Further, how do you show, how do you excel, how you contribute, that is what is going to make a difference. And all functions are equally important. There is a saying, if you always do what you always did, you will always get what you always got, okay? That is where the role of this seminar, innovations, come into picture. So you have to be innovative. For yourself to be recognized, you have to be innovative in whatever field of work. Even if it is counting some pebbles also, there you can find a way how you have to count the pebbles more effectively. Okay, that is where you can make a difference. You have to always think for fresh. Automation in testing, depending on area, there are so many things because of time, but you can definitely make a difference if you apply your mind. So to prepare for the new job, identify the technical skills required for that specific job, and subject knowledge, associated literature. You have the tools, what are all different I have listed. But for your job, whatever tools are required, obtain mastery over that. And design rules, supporting disciplines, and people who can. Yeah. Oh, okay, right. He is worried about my safety. Anyway, I was heading a safety wing at QA. So, at ISRO, okay. All ISRO safety, so no, don't worry. So, supporting disciplines and people who can. It is very important to be networking with people. So identify people who can help you. While doing that, choose a right person. Somebody like Professor Vishwanathan, who is so dynamic at this age also, how he is moving around and all. Choose such people, not people like Prakash Rao, okay? Choose the right role model and key people who can help you. I think Dr. Siu's story, I will not, time is not there. Okay, no problem. So some facts, these are the things you have to, whenever you are dissatisfied with what you are getting, remember these things. Always we find a problem with the system. Anything, our solution is system is not conducive. It is not the system is within us only. That if you remember, these rules, if you golden rules, if you remember, no pains, no gains. Everyone feels they deserve the best. No one can give everything to everyone. This is very important. See, in ISRO itself, if you want to give incentive, I can tell foreign trip, promotion, or some award, or some, okay, something like that. There are different. But Kalpana cannot get foreign trip also, promotion also, reward also, award also. That sorry, Kalpana, you are in front of me, so I am telling. But Prakash Rao also is fine, that's why. So one person cannot get all the things. System, what when they do as a manager, when you are there, you want to satisfy all the people because everyone has to contribute. Somebody will be given foreign trip, or somebody who could not get promotion, consolation, you may send him for 2 days trip to Singapore or whatever this like that. So it is like that. So never feel that I did not get this. The biggest problem for dissatisfaction is 2 things. One is the comparison. You are not worried that you did not get it. You are worried that other person got it. She got, but I did not get. That is the killer actually. So as long as you don't compare yourself, it is fine. You will be able to move higher and higher. So jealousy and comparison, these 2 things, if you can eliminate in personal life also, it's very easy, but it is never going to be done, okay? Yeah, that's what I was telling now. Everyone feels they deserve the best. I was telling earlier. So you feel you are a tiger or lion, but you may be really cat. That only the system, performance appraisal, no, that is for this text actually. No performance appraisal system is foolproof. Everybody thinks I should get, correct, no, Hari? Okay, he is my friend. So he attended some of our in-space courses and he is attending next one also. So like that, we feel that I should get this and all. But actually, there is a committee to assess. And every time they cannot be correct. That is also fine. Statistics you have to allow. Okay. Then other important things, soft skills, communication skills, okay. That is very, very important, but today's generation, I don't think we need to tell about communication skills, but after seeing 1 or 2 students' presentations, they are able to present so much wrong concepts also with such an authority. So skill is good, but the concept is wrong. That is also not going to work. So first you have to be strong in your subject, then you have to communicate it correctly. A wrong concept, communicate very strongly. Actually, you are spoiling 100 more people, okay? If you have no skills, it is okay. But when you tell, be sure yourself, not for sake of presentation, but first you have to master before you talk, okay? That is one thing. Oral, written, listening is another skill. Listening skill is the most difficult. In a family, if you take between husband and wife, that is the toughest problem. Any wife you ask, she feels that husband is not listening, okay? And he may have a very strong reason for not listening also. Okay, that's a different subject altogether. And usage of statistical tools, because nowadays anything is there, people want to see metric, but generally statistics, I'll just tell reliability, we'll tell spacecraft reliability is just 2, because it is hungry time, If you are hungry, you will be angry. So I don't want you to be angry with me. So I will tell you about this one only about reliability, we tell 0.99999. Then the chairman himself will ask sometimes, what happens, Prakash Rao, if it is 0.99998? What we can tell? So then anecdote is there. 2 friends have gone to visit Egypt, some monument, they have seen pyramid or something. So one friend told loudly, oh, this looks so beautiful. What it could be age? Immediately other friend told, it is 2,000,002 years old. Friend was surprised. How are you able to tell so correctly to 2,000,002 years, 1 ppm accuracy? What is the dating technique that is available to determine to 1 ppm accuracy, can you tell? No, 2 years back I visited. That time curator told me it is 2 million years old. So this is what all statistics and all, but still you have to be good in statistics, okay? Don't make this one. So this you can see after launch of one of the failure in the early stages, maybe SLV or ASLV. The person in red shirt, you can identify Somnath sir. okay, who was the previous chairman. And that time he's so young, you can see. He was looking as young as me now. Okay, only hair is the difference. Okay. So you can see they are all stalwarts of ISRO. Okay. So forget what hurt you. Forget what hurt you, but never forget what it taught you. So as Kalpana also told, you'll never get destroyed by failures. Okay. So as long as you are not disturbed by the failure, you can definitely move forward, and this can lead to this. If ISRO has stopped at that time learning about, keep on telling that I failed due to that jet, then this stage would not have come. This is Chandrayaan-3 success all over India. Okay, all over India, people were celebrating as though it is my own success. So that will come only because of the relentless efforts, irrespective of the results. Yeah, yes. So documentation, this is one boring activity for anybody, including me. Okay, so because you have to write something what you have done, that is the toughest job, but you have to do it. There is no other alternative. So when W2M, our foreign contract, when we got, our engineers, we do a lot of documentation ISRO, but they were asking much more. That time I was the interface between designers like Kalpana and actual people, whoever is that ASTM side customer, okay, Eutelsat. They were asking so many documents. I have a problem. Once I told Stefan, this is a problem, why you are asking so much of documentation? He told, Prakash, remember one thing, the only thing left on the ground after your spacecraft is in orbit is the document. So then it struck a powerful message to me. Anything you want to know about that, requirements, contractual agreements, design, analysis, QA analysis, fabrication logs, reports, anything you want to trace, document is important. You want to reproduce Chandrayaan-3. How do you do it? Satellite is there. You have to do only based on documents. So never ever, students, you never feel that even today when you have done some work, the documenting it is more important, especially software. If you join a software company, need not be ISRO itself. If you join there your code, you will be, because in 1 year if somebody offers you double the salary, you will leave and go. But the company has to continue that work. How they will continue? Unless your code is having appropriate comments. Without comment, a code is dead. It's as good as not there. So that is another important aspect, documents. Then why documentation is recollection, reproduction, records, results, reviews, reassurance, change of guard time, all that is required. Okay, this was, I don't know, I have to stop it. How many are here feeling hungry, last bench? Okay, hungry people. No angry people, okay, fine. You are feeling hungry. A monitor is feeling hungry. Okay. Okay, fine. Just this incident I will tell. So this was, you can see here the metro. The metro is coming out of an aircraft. So that aircraft is a cargo aircraft. Cargo aircraft is something where you know people will be there except the pilot and the crew. And you can see spacecraft. See, I am there in the middle, in the bottom left. Okay. And this is inside of cargo aircraft. So what happened when we went to our own spacecraft, GSAT-18, for which I was project director, when we went for launch, the spacecraft contained, we were started, our testing we have started, but Japanese, they brought their own spacecraft. Their container has become like this. When they brought from airport, tarpaulin was there, they removed the cover, then their container was like this. To see whether spacecraft is damaged or not, they have to drill some holes. Where to drill holes? To analyze, it took 2 days, because you should not damage while drilling the holes of the spacecraft. So like that they did, and it was damaged. They went back 2 years. Their spacecraft has lost some hundreds of crores they have to spend to repair and all. But theirs is okay. But we were just co-passengers with them, and we had to suffer. We waited 3-4 months to have another passenger with us. But why it happened is, during takeoff and landing of the aircraft, there is a pressure difference happening, as you are going. Then every spacecraft container should become like this. But it won't, because we have got something called breather valves. They will be there all around the container. They will be equalizing the pressure by letting or closing or opening. But here what happened, Japanese, I think they have tried, because it was a military spacecraft, they have tied it with a tarpaulin, no one should see or something. They should have removed that before loading into the aircraft, which they have not done. So what I am trying to tell is, smallest detail missed can lead to very disastrous consequences. So devil is in the detail. Pay attention to detail. If everybody wants to be big picture guy only, okay, it won't help. somebody has to go through very in detailed way. So pay attention to detail. That also we have another thing, last minute untested improvements lead to 100% failure rate. Okay, so that is one thing. These are unwritten doctrines of SWAFE. If anything can go, Murphy's law. One test is better than 1,000 expert opinions. That doesn't mean experts are not required. Tomorrow, if you want your CanSat to be reviewed, call me. Okay, I will come. So you can just be tested, sir. Prakash Rao not required. Don't say that. Both are required. If you cut corners, space will not forgive you. Last minute, okay. This I have told you yesterday. Okay, that we will leave it. But interface is very important. I have so many examples, but no time. Then this is another important aspect, honesty. How a simple truth is. Once we found that after vibration test, some component broke. We had to do so much analysis. Finally, the thing was, a component while wiring was dropped by the person. He has taken back and wired. So that came back only when we tested vibration test. Luckily, it came back. Suppose it was same was used in Chandrayaan, and after vibration, because of the launch vehicle vibration, if it happens, you will lose the whole mission. So there the people have to report immediately. Here he was not aware. But even when you are aware, when I was testing, not with Kalpana, but you remember, Vijaya, with them when we were testing, we reversed the voltage. Instead of +5, we gave -5. Afterwards, this package is working. Now myself, Vijaya had a dilemma to report to Koteshwara sir that it reversed or not. If I don't tell also, he will not know because system is working. It may work today, but after going into orbit, it may fail. So honesty is very, very important. You assume in human space mission, if you do such mistake and somebody loses life, you know to your heart that it is due to your mistake. Can you forgive yourself in your life? Never. Yeah, we will never forget ourselves. So be honest. That is very important aspect. Even if you get some scoldings immediately, even if you are going to be suspended, it's fine. It is the overall organizational interest that matters. Though we have come a long way, we still believe space will not forgive you if you make mistakes. So don't make mistakes. Okay, these are all general things. Be ready to help and also seek help. Seeking help is very important, but you should go to the right people. So asking help is not you need not feel insulted, and have good, and never criticize your office in public. In private sector, if you do that, you will be dismissed immediately without even whatever that relocation benefits, not relocation, whatever retrenchment or whatever that benefit also they will not give. So never publicly you don't, whatever is there private means only to yourself, not to your brother or sister or bro or all that, okay. So bro, daddy and all are here only, not after going there. So we are accountable. Another important aspect is social justice and gender justice. Social justice, when I say it's both social, this one as well as gender. Please be aware that there are laws which protect, there are some people who were ignored for a long time. So that, and gender-wise also, never make comments which are gender-specific or a particular caste-specific and all. You can end up in jail. And password security is another most important. Never reveal your password to any of your closest daddy, bro, all the people also. So you have to keep it, because anything happens on your account, you are liable. I know examples, I have no time to explain, but people can end up in jail. I know from my own colleagues where I was group director. So never reveal your passwords. Okay, this you have seen, and I think I'll stop here, sir. When you are not there, I told them, you have to choose right role model, like Viswanathan sir, not like Prakash Rao sir, okay? Right, sir. Thank you.
Thank you so much, sir. It was an energetic presentation. It's time to honor.
We have to be extremely thankful to Prakash Rao sir, because he has taken 2 days to be with us. 2 lectures he has given untiringly. He has prepared a lot of information. So, MGR University, and on behalf of you, wholeheartedly, one thanks is not sufficient, sir. Crores of thanks to you. You are benefited for our students, and always you are encouraging. I gave your email ID to our students, so they will ask questions through mail and help them. Thank you very much, sir.
It's now time to honor our guest speaker, Dr. Prakash Rao, PJVKS, Chairman, Project Monitoring Committee. It's now time to felicitate our session chair, Dr. N. Kanya ma'am, HOD IT and Dean ENT Affairs. And co-chair of the session, Dr. Jayalakshmi ma'am, HOD of EC department. Thank you, sir. Thank you, ma'am. We break for lunch. Lunch has been arranged at Mother Teresa Block, 2nd floor. Do assemble after half an hour.